네, 안내 말씀드리겠습니다. 곧이어 10시
May I have your attention, please? From 10 o'clock, we will start the Joseon session, shipbuilding session of the 19th World Ocean Forum.
for the 2025 World Ocean Forum will begin at 10 o'clock very shortly. So may I please ask all of you to please take your seats. 본 세션에서는 동시 통역을 제공해 드리고 있습니다. 영어와 한국어 동시 통역이 제공되고요. 앞에 놓여 있는 수신기를 착용하신 후에 한국어 통역은 채널 1번, 영어는 2번으로 맞추시면 되겠습니다. We provide simultaneous interpretation service for you. If you require interpretation either in Korean or English, pick up the device in front of you and tune to channel 1 for Korean and channel 2 for English. 자리가 정돈되는 대로 행사 시작하도록 하겠습니다. 통역 안내 한 번 더 말씀드리겠습니다. 동시 통역 제공이 되고요. 앞에 놓인 수신기를 착용하신 후에 한국어 통역은 채널 1번, 영어 통역은 채널 2번으로 맞추시면 되겠습니다. 한국어는 1번, 영어는 2번입니다. We provide simultaneous interpretation service for you in Korean and English. And as you could see on the screen, pick up the device in front of you and tune to channel 2 for English and 1 for Korean. 네, 2025 제19회
Welcome to the 19th World Ocean Forum 2025 Shipbuilding Session. Let me introduce myself. My name is Yoon Soo-rin, MC for today.
반갑습니다.
Nice to meet you all.
네, 본 세션은
This session is a global forum with speakers from both Korea and abroad. We are broadcasting this event on our Korean and English channels on our website and YouTube. If you visit our website, you will be able to download the material and you can enjoy real-time Q&A. So whenever you have questions to our speakers, please leave that in the Q&A chat room. The shipbuilding session will be held under the theme of Paradigm Shift in the Shipbuilding Industry and Opportunities presented by MASCA. We are now facing a confluence of challenges: the era of global maritime supremacy, decarbonization, eco-friendly vessels, and the grand digital transformation. In order to respond effectively, we must have a clear understanding of the essence of the shipbuilding and maritime industry, focusing on connectivity, inclusiveness, and resilience. And we will have to adapt to the changes posed by the challenges. We have invited many good speakers for the session, and there will be presentations and panel discussions, and we have ample time for this. I hope that we can exchange deep insights throughout the session. So let us begin. So let me introduce the moderator for this session. We have Mr. An Kwang-hun as a moderator. Mr. An has served as a president of HED Hyundai Heavy Industries and HD Korea Shipbuilding and Offshore Engineering. He is particularly well known as the key figure behind the development of Himsen, the Korea's first independently developed engine, which holds over 35% of the global market share. Currently, as an advisor in the field of eco-friendly marine engineering and energy solutions, he is a respected leader guiding the future of the industry. Now, let me introduce Mr. An Kwang-hun onto the stage. Please greet him with a big round of applause. Good morning, ladies and gentlemen. So it has been 3 days since we kicked off the event. And again, in the Haeundae area, we are having Komarin event. And I know that many of you had to travel from here and to Mexico to attend Komarin. And I would like to thank you all for taking time to participate. As you know, the shipbuilding industry, in case of Korea, we have the world-class competitiveness. And yesterday, we had Komarin and the World Ocean Forum together. So I know that it has been a hot issue for overseas clients and overseas participants. While staying here for 3 days, I could see that many participants are greatly interested in the shipbuilding topic, and we have very renowned speakers and presenters. We have invited global key figures in the industry sector. They have ample experience and know-how as well as knowledge. And I would like to thank all our presenters and speakers for their time, as well as the participants, our online and offline participants. I extend my sincere gratitude. I hope that today's forum can be a meaningful one. This year's shipbuilding session has been designed to shift the World Ocean Forum's identity toward a more practical and future-oriented theme. So we have covered many new issues and new items. The World Ocean Forum always think about the future, not the past. Therefore, I know that we have many guests from around the world. And the reason why they have great interest in the shipbuilding sector of the Republic of Korea is because we are the leader in this field. So setting the direction forward is a very important one. When it comes to future energy or environment, shipbuilding industry encompasses all that. Many people say that we are living in an era of uncertainty, and in terms of geopolitical power struggle, we need to check where the shipbuilding industry stands. conventionally, many people thought that the shipbuilding industry is a manufacturing industry. So people think that it's a very conservative industry. But in fact, as we are living in the fourth industrial revolution era, now we are standing at a more advanced transition. Therefore, we need to talk about digital transition, climate change, net zero fuel, SMR. That's why we have invited the speakers who can cover those topics. Today, we are going to cover all those diverse topics. So for the first presentation,
Let me invite MT Korea President Kwon Oh-ik. The topic of his presentation is development of the next generation icebreakers and eco-friendly vessel for the Northern Sea route. He is a CTO of Daewoo Shipbuilding and Marine Engineering, leading the decarbonization and the digitalization of the shipbuilding. Due to the development of the Northern Sea routes, the most hot issue is the technology. Of course, we have other political issues, but the most important thing is technology. So I think he will deliver you the great insight about it. So then we will invite Odin Kwan from the MT Korea. Please welcome him with a big round of applause. Good morning, everyone. It is early morning, and I'm so honored to become the first speaker of today's session. The main topic of this session is the MASCA. So if we have a second revival of the shipbuilding, the naval vessels and the icebreaker will be the main item. So using this opportunity, I hope that the Korean shipbuilding and the MASCA can advance further. So today I want to talk about the development of the next generation icebreakers and the green ships for pioneering the new Arctic Sea routes. So this is content. So I will talk about the polar shipping routes and then the requirement for the icebreaking vessel and then the design and next generation icebreaker and then followed by the risk of the Northern Sea routes and the future propulsion system of the Arctic ships. As you know very well, global warming has the two sides of the sword for the northern Arctic area. It is the environmental disaster, but in order to reduce the CO2, we have to develop the new routes. But so far, we had the northeast routes in the northern area, and we had the northwest routes in Canada. And if we have a melting ice, we can have the new routes of the Northern Sea routes. We are not sure when it will be done, but in 30 years, 40 years, if ice melts, maybe we will have the new routes, which going through the Russia. Then why we have to think about the NSR? Because we can save the time and the cost and the pollution. So from Busan to Rotterdam, it's 21,000 nautical miles. But if there is any problem in the Suez or the Red Sea, it's like 24,000. But if we go through the Arctic, it is 13,000, saving the 8,000. But if we go through the Panama to New York, it's a total of 18,000. But if we use a northern west route, it's a total of 13,000, saving the fuel and cost and the time. So that is just the mathematical calculation. Of course, we have a lot of the issues and the risks there. So speaking in other way, the significance of the northern sea routes and the bad side of the global warming gives us like a possibility of saving time and also imposing us the risk of the geopolitical issues. Europe and Ukraine and the Russian war make the limitation of the export of the gas, and then the solution can be the ice-breaking vessels. So we have advantage of the northern sea route with the saving time and the cost. Also, we can have the new sea routes as a benefit. Then the fishing can advance too. But there is a bad side. There should be the destruction of the ecosystem, and many due to the rising sea level, many cities and the area will be submerged. So we have a jet current in the Arctic, and it will give the turbulation. The cool air will come down to the middle equatorial line. So we have both sides of the good and bad about this melting ice. From December to April, the Arctic area is covered by ice. So the vessel going through the Baltic area, they have a ice class. So it means that the icebreaker break the ice first, and then they follow the route. Depending on the thickness of the ice, they have a different grade. So the thicker the ice is, the higher the grade is. So this is a requirement based on the ice level. So polar code is decided by the IMO. So we have a PC1 to PC7. So PC1 is a year-round operation. So so they have a PC1 for the year-round, and we have a PC7 which can be used during the summer and the autumn. And we also have other requirements, ISO 1 to 3 and ARC 3 to 7. So the Deus icebreaker was ARC 7, which can break the 2.7 meter of the ice. And the Finnish and Swedish are operated in the Baltic. So they have a Super 1A, 1C, 1B, like Lithuania and the Baltic Sea, to the St. Petersburg and to the Bothnia Bay in the Finland. They have a limitation of the vessels. So if depending on their grade, they can go into the Arctic. So because the thickness of ice change continuously, so they have to receive the grade to go through. Then what kind of requirements this ice breaking has to have? If we look at the length of the vessel, they have the anti-ice breaking structure. So they have the ship's hull can be divided into the several areas. So they have different hull construction requirements. So depending on the depth of the thickness of the ice, all the requirements for the vessel itself is different. So we can build a new ship, but if we do the retrofitting, it will be very complex project. So we have various design parameters. So I will take the example of this icebreaker. For the ice breaking, and then they also deliver the cargo. The most important thing is the outside external air. And in the Russia, it has the very cold air. It can drop down to the minus 52. But the usual commercial ice breaking cannot stand the minus 52. So all the heating mat should be equipped outside. So it has to have a condensation prevention or the thermal requirement for the a total minus 80 degrees Celsius. So even during the snow windstorm, the vent can be prevented. They have to have a special vent so that the only air can come through without any ice. So they have to have a double structure. So it is a war against the outer air. Also, to break the ice, which can go maximum 2.1 meter, it has to have a special bow structures. And this vessel should have the various movement. So they have to have a special bow area and the a stern area. Then the ice special propulsion should be equipped with too. It goes to Arctic area, but it goes to the open north too. So they have to combine the function for the ice and the open water. So Titanic hit the iceberg, but what should we do if we have the bigger iceberg than that? All the size and the weight and the load of the ice are simulated like this. So whether it is hit which side, which side is hit, and we try to reflect that into our research. And then this is a double acting. So the 1 year ice is usually 1.5 and it goes to the both side. But if we meet the channel, the ice get thicker. So we need to have both sides action. And the result was same according to our research. So depending on the structure of the vessel, the ice breaking performance is different. So after this kind of simulation, we came to the final design of the icebreaker. So Russia has the most number of the icebreakers with the total 41, and then the Finland has 11. The Russia had the icebreaker after the war. As the compensation, the Russia got the icebreakers. That's why they have a lot of icebreakers. And also Canada has 20 icebreakers. And so they made the twin icebreaker before. So if there is any a failure, they bring the parts from the another twin boat in case of the USA. So the USA is now going forward the icebreaker, as you know, and also China has 5 icebreakers, which is purged by the nuclear power, and also the Korea will equip the SMR into the icebreaker so that we can use nuclear energy in the icebreaker. So we have the Arion research vessel, but that is old now, and that is small vessels. Capacity is just 1 meter. So we decided to build the new icebreaker. So now we are making the new ice-breaking platform, and we went to the northern Arctic and the Antarctic so that we can make a research about the ice breaking, and we already started the design stage, and we made a contract. Within 2 years, we will have the new icebreakers. So this new icebreaker will open the new path so that we can continue the research year round and do a more in-depth research with high-tech equipment. And also we made a boat very comfortable and eco-friendly so that this vessel can be operated in a safe manner. So it's under the development now. The Hanaosha will complete these new vessels. So this is a comparison between the Arion and the new generation icebreaker. So previously Arion was a 1 meter 3 knots, but the next generation new icebreaker will be the 1.5 meter 3 knots. And also it becomes azimuth thruster 7.5 megawatts, and also the tone class became the double. And also it can accommodate up to 100 people on the bigger boat. And also it has a moon pool in the middle, so they can do the diving in the vessels. And on the left side, since 21, Daewoo and Samsung Shipbuilding conducted research about the icebreaker. So the ice-breaking oil tanker or the ice-breaking container ship. So in the Wapping Island in Canada, the minerals should be delivered year-round, so that's why they made an R&D concept of this. But they are in a difficult situation of their operation, so they cannot build a ship yet. So this is at 4,000 TU, and it has. We have the ice pool. For the simulation, so they can do all the simulation and test the equipment in that facility. So Korea can do all the tests related to this icebreaker in the Arctic area. So by 2028, I believe that the Korean icebreaker can navigate the Arctic area. So now the U.S. is trying to make their own icebreaker. This kind of movement started from the Biden administration, and they are pushing this project continuously. And also the Canadas are moving toward the icebreaker too. So one of the background of the MASCA is to have the gas vessels in the Alaska. Tundra is melting due to the global warming, and they have submerged the ground. That's why the pipeline is destroyed. So they tried to build a new pipe. And we suggested the liquefaction on site instead of the delivering the gas. So if the another transshipment port can be the option. So that's what I suggested to them. Of course, ExxonMobil tried to do this, but the Trump decided to build a pipeline. But I believe that if there is any change, my suggestion can be an option. So between the Qatar and the Alaska, the temperature difference is around 100. So the only way Korea can advance is to make an icebreaker and do a great job in the Arctic area. So the U.S. wanted to build the 48 breakers, as you saw in the media. So Trump had a talk with the Finland prime minister, and the Trump already ordered this to the industry. But this is not a naval vessel, so I believe that maybe we can have some opportunity. This is a LNG tanker, fourth generation LNG tanker, and on the left side you can see the icebreaker research vessels, and here on the bottom on the left, this is a Russian next generation nuclear propelled icebreakers, and on the right side we have a Chinese icebreaker and the US icebreaker. So Korea tried to use the SMR in the icebreaker. Maybe we can build, Korea will build the icebreaker, this kind of icebreaker. The risks of the Arctic navigations are meteorological factors and the technical factors. We have a sea ice and floating icebergs and the special currents in the Arctic area. And the water depth is 10 meters, but they have a lot of islands. So this natural risk can give the damage to the vessels, and there are some a limitation of the vision, because they have the white night and also the dark time, dark duration. So there is some limitation of the vision, which gives a delay of the navigation or the risk of collision. And also there could be some malfunctions of the navigation equipment and the communication failure. And also there is no charts and the location systems. So when we have the second generation icebreaker, we need to make our own chart, I think. And the modern charts in Arctic waters are only 10 to 15% complete. So Inmarsat and Starlink should be utilized for the smooth communications. In 1912, April 14, 2340, the Titanic collided. But just within the couple of hours, it sank. I read the story. Titanic could not fall, but they had a vertical wall, but they didn't have the long horizontal walls. So if they had a vertical wall, it would not sink like this, I believe. So it navigates in night. It looks quiet, but it can collide into the iceberg without any warning. So there is no rock in the Arctic area, so our icebreakers are navigating well without an accident yet. Also, there are another like risk factors of the operation factors like environmental protection factors. So we also have the qualified the iceberg navigation operation, and we don't have enough port for the evacuation. So we also have to receive the approval from the Russian authority for the NSR. So we have a continuous discussion how to avoid this kind of risk. So many people say that the going through in the middle route is the answer. So in a polar court, HFO was banned because the bunker C cannot be cleaned from the iceberg, leaving the permanent pollution. So there is those kind of environmental factors, and also we need a environmental compliance, regulation compliance. So those can be the factors for risk factors for the Arctic navigation. And among like 1,700 ships, there was a 531 accidents in total due to the failure of the machinery damage or the failure of the equipment. And also they had the capsizing or the wrecking, or they had a fire or explosion, and also the collision. And the fifth top cause was the contact to the harbor wall. So left side, you can see the vessel going through the Baltic Sea. If they don't have the anti-ice equipment, this kind of wall can be broken like this, and the propeller can be bent. And then the third picture the accident due to the lack of the stability. So the safety is first in the Arctic navigation. This is the Victory 50, which is pride of the Russia, but that was stuck in the ice. And it didn't make a wrong turn, hitting to another vessels, but there was no damage or the casualties, but then they had to fix it there. So even the nuclear propulsion icebreaker, if they cannot operate well, there could be some accidents. And in the Arctic area, we have a continuous icing accumulation, reducing the stability. So we are making this kind of loading control, and then there's a requirements of the IMO or IX, like a vertical and the horizontal load. So we have to have the curve of stability like this. And then that should be reflected into the design. So before having this kind of ice, nowadays all the vessels are equipped with the heating mat so that it can operate even with the heavy snow. And also sometimes they can cover the vessel with the special materials. So then what kind of fuel should we use? We have to go for the zero carbon fuel. Now they're moving the LNG and methanol, but we have to completely go for the green methanol. And so far the best is LNG, and it will be followed by ammonia because it doesn't have any carbon. So the ammonia, hydrogen, or fuel cell, hydrogen fuel cell will be the mainstream of the vessels. In the IMO 83, the net zero was delayed. Maybe that was the push by the Trump, but I believe that it was a very sad news, but we have to go for the zero carbon with the green ship. So another option will be the nuclear energy. From 1960s, we had a nuclear propelled proposed vessel, but after Fukushima accident, they didn't talk about it. And now we are moving forward the zero carbon. We talk about this nuclear energy again for the vessel. So the Victory 50, the Russian vessel, can operate 6 and 7 years with a small size of the nuclear reactor. And with the molten salt rock, the Samsung received approval from the Korean registration, and Samsung and Hanwha are using the different solutions. The Hyundai is using the sodium-cooled fast reactor, and the Samsung is using molten salt reactor, and the Hanwha are using the thorium molten salt reactor. So they received approval from the KR, but the acceptance is a very important issue. But I think this will be realized in the near future. All these ships can go to the Arctic area. I believe that we also have the researcher from KAERI, and then he also answered that the small modular reactor can be the answer for the icebreaker. So for the Masca, we have to be equipped with this kind of the icebreaker, so that the Korea can build this kind of icebreaker for all across the world. Thank you very much.
다시 한번 아주 유익한
Once again, thank you for your insightful presentation. Please give him a big round of applause once again. Moving on, we have invited a very busy speaker joining online. I would like to introduce Mr. Lee Kang-gi. President Lee Kang-gi will present on optimization technology for green shipping corridor using next-generation eco-friendly fuels. Please greet him with a big round of applause.
Very good morning, everyone. I am Professor Kang-gi Lee, or I think in my respective society, I am known as a KK Lee. That's a nickname. And I have a couple of caps. I'm still a professor of Clayfeather University. I'm from Korea Maritime University in Korea. And then I moved to Europe, and there I have decided to reside there. And at the same time, I'm MD of Solano Marine. And from this year, I don't know what reason, what background, but Korean Engine, Manufacturing Association have elected me as their representative. So I'm again reconnected to Korean entity. So. Also, I very much like to thank. This is really great honor for me to be here to presenting what I have studied, and also what is my opinion about new fuel, and also especially to Mr. An, who is chair of this session, and also organizing committee. Thank you very much. Hence, there is lots of participants in Korea. They are mostly startup and young, let's say, businessmen. I was told from the organizer, so it would be nice that I start to switch to Korean, as they need to have a little more clear understanding. Thank you. 여러분 감사합니다.
Thank you. Today I'm going to talk to you about next generation green fuels. There are many discussions over this, and we had to arrange many things throughout the sessions. And together with other institutions, we had many discussions so far on what kind of future fuel will be beneficial to protect the environment. So we thought about practical choices and practical options, and we concluded that ammonia will be the next generation green fuel. So that's the consensus that we have reached. And I think that's practically and technically possible. So that's why I have chosen ammonia and hydrogen carrier to be the topic of today. So based on that consideration, let me first cover vessel fuel part. So let me discuss the conditions for maritime fuel and history of maritime fuel. And second, let me cover why that is so important, especially for Busan port. And Busan, the city with a big major port, because the fuel impacted the city a lot. So let me cover that. And then moving on, in the main part, I will discuss about green shipping corridors, the status of green shipping corridors. As we have many young businessmen and startup entrepreneurs, as mentioned before, let me cover what kind of technological challenges exist and what kind of opportunities exist, because whenever there is a challenges, there can be opportunities. So there will be the last part. Many institutions and companies assisted me for this material, so there's a disclaimer. Please use it for educational purposes only. When it comes to maritime fuel, there are three major conditions. As we use a lot of fuel in the maritime sector, it should be price competitive because vast amount of fuel is used in the vessel. As vessel fuel is used in a confined space and stored in a large volume, there should be safety. And second condition is safety. And vessels move across the world. Therefore, vessel fuel should be available across the world, and another condition is availability. In the new millennium era, there is one condition added to this, which is environment. So these are four major conditions for the maritime or vessel fuel, but the fourth newly added element is the most important one nowadays. From that background, in the past, the history of maritime fuel began from the steam engine. And using that engine, we have started to use the vessel at the time we want and whenever we want. And that was made possible thanks to solid fuel. Using the steam engine and moving on until 1912, for about 100 years until 1912. The only vessel fuel was coal. And at the time, what's important was to have that coal resources, and a major institution focused their efforts on gaining coal. After the birth of a diesel engine in 1912, it has only been since the late 18th century. And early 1900s, we started to design the engine to fit the vessel. And finally, in 1912, we started to have the vessel engine that can use the diesel power, and since then, the vessel started to use the diesel in an accelerated pace. This is a phase where the vessel fuel turned solid to liquid. The shipping company which has used the diesel fuel for the first time was a very innovative one, because there was only one oil station at the time, but they were so innovative, but started to use the technology. They had the trust toward technology, and at the time, the shipbuilding company and shipyard had that technology to build the diesel engine and diesel vessel. But what's surprising is that within only 20 years, every vessel turned to diesel. It was like an industrial revolution. All the vessels across the world turned to diesel in a relatively fast pace. And I worked for Daewoo. This is a Daewoo vessel, and I guess it was at the same time. Now we are talking about Masca, but in 2012, Daewoo prepared for Masca, and we prepared for Masca even in 2012. So we supported the technology to the U.S. Navy and U.S. commercial vessels. At the time, there was a container vessel that belonged to NASCO, and we successfully engineered and designed the LNG carrier for them. It was in 6th of December 2012. It was 100 years since then. So again, 100 years for solid, 100 years for liquid, and since then we are using gas. When turning to gas fuel, there is a fast-paced development. Again, the transition from liquid to gas took 100 years, but when we started to use the gas, we have started to discuss about environment. So there's two different categories, carbon fuel and zero carbon fuel. But practically it is very difficult to get that net zero carbon fuel. So that's why we are talking about net zero and zero carbon fuel as a new type of vessel fuel. So from RS, let's see, the Korean government and POSCO sponsored and Ilsin Haeun built the LNG carrier. This is the real LNG carrier. According to the IGF code of IMO, it was the first time ever that we have used that code for the LNG carrier. As you may have seen from the news media before, I guess you must be familiar with this, but you're using methanol vessels and we are currently building that. And Denmark AP Molas placed the order for that. Again, as you well know, Japan MIK has placed order for ammonia vessel, and it will be delivered in 2026. Earlier than that, Kawasaki Heavy Industries placed an order for liquefied ammonia vessel. Now we are in earnest in a liquefied gas era. So the reason why these fuels are important is because at the point of at the port, ground transportation and maritime transportation meets there. So ports should be prepared to accept different modes of vessel and different modes of fuel. Infrastructure is needed, and at the same time, when the maritime cargo comes in, it should be transferred to ground transportation. So that's why the role of port is so important. So let me give you an example. Due to many consideration given to decarbonization, so we have equipped the port with very low sulfur fuel equipment. When using very low sulfur fuel, or whether we process the sulfur fuel on the vessel, we can choose two ways. One is to discard it to the ocean, or the other way is to take the sulfur and transfer it to the ground equipment. So let's say when we sequestrate the sulfur, and when, as you know, sulfur is a heavy fuel. Let's say the vessel used around 100 tons of sulfur, then tons of fuel, then sulfur is created by 2.5 tons. And for long journey, it takes around 21 days. So this means that around 50 tons of sulfur is being created. So the 50 tons of sulfur should be discharged at the port. Let's say the scenario of discharging the sulfur. Nowadays, ports are being automated and digitalized. And think about 50 tons of sulfur that should be carried through that equipment and infrastructure. As we are very concerned about the environment and climate change, and I know Busan is experiencing that climate change during the summertime, it's a rainy season. So, against this backdrop, to process 50 tons of sulfur during the rainy day, then that will become H2SO4. When H2SO4 is leaked to that automated port, imagine that scenario. And again, port is prone to typhoon, a very strong typhoon. And then that is really risky for the ports. I've mentioned about 4 different next generation fuels, and all those next generation fuels, as you know, they have characteristics. Methanol, ammonia, especially, they are toxic gas. And hydrogen, it is prone to explosion. It easily gets fire. And another fuel needs cryogenic environment. When the cryogenic gas gets on fire, then we need to use certain specific substances. And in case of ammonia, when it is in gas state, it moves around, and when the concentration level goes up, then it may create suffocation. So these fuels are really risky and dangerous, so that's why the processing and management method is so important for the next generation fuel. As ports are becoming more digitalized and autonomous, then these new next generation fuels will face a lot of challenges. Vessels, when discharging their cargo at the port, they get refueled, so refueling system should be restructured again. Now let's think about logistics. Let's say we are moving cargo from point A to point B. So the point A will be the manufacturing site, and the point B will be where customer gets the product. If we see all the stakeholders and put it onto the map, this is the map that we have. And after putting onto the map, we need to think about the environment. In this picture, what kind of role the vessel should take at the considering environment and vessel operation at the same time is a really difficult thing, but the attempt is being made by green shipping corridor from point A of the vessel to point B of the vessel journey. We are trying to make it green, and that's the concept of green shipping corridor. To have that, we need to use net zero or zero carbon fuel. In that case, as I have mentioned before, we need to use new port infrastructure and bunkering system. And that can be a global decarbonization testbed. Whenever lesson is learned, then we can transfer that to global vessel operation and make a protocol based on this. There were 22 green shipping corridors in 2022, and it has been increased to 57 in 2024. There is a competition and collaboration at the same time. Key routes is between Rotterdam in Singapore and Shanghai to California. In case of Korea, we are doing a test for Busan Ulsan in between Seattle and Tacoma. The two governments are closely cooperating for the green shipping corridor. This will be the first trans-Pacific green shipping corridor in Asia. And then the volume that is being transported may depend on the vessel size, but one vessel's decarbonization effect will be the same as annual emission reduction equivalent to 32,000 vehicles. And the reduction amount is so huge. As mentioned, it's equivalent to 32,000 vehicles. This is the announcement made by Ministry of Oceans and Fisheries of Korea. This is their goal to have that green shipping corridor. The engine power, starting from the vessel with great engine power, that would be PCTC. When container vessels, we have many PCTC and container vessels. So based on the two models of vessels, the Korean government and the U.S. government reached an agreement to have a green shipping corridor. And now that's in operation. And other than that, there's an attempt to scale that up. After a successful pilot project and after having the protocol, we are going to expand the route to have the Korea-Australia green shipping corridor to have stable energy supply. And another thing is between Korea and Singapore GSC for the same purpose. And we are doing a lot of technological collaboration with Denmark. So for technological collaboration, there is another agreement reached between Korea and Denmark. The thing that I would like to focus on today, or focus on while mentioning this, is that regulation impacts the industry. And let me dig it deeper on what kind of impact it has. This is IMO's strategy on GHG reduction, which is their strategic regulation. But unfortunately, last week, in MEPC 83, the GFI concept, everybody believed that GFI concept would be approved, but contrary to that belief, it has been suspended for 1 year due to geopolitical situation. Many people got shocked, but it doesn't mean that it is all abandoned. So the efforts that has been made so far should be sustained. This is IMO strategy, and if you look at this, their strategy is to try and make 5% of shipping fuel into zero emission by 2030. This means that 15.8 million tons of HFO, when that is converted to ammonia and methanol, they have different energy density. It will be around 37 million tons. So you can see the amount of fuel that's needed. 37 million tons of fuel. A year, we need around 200 million tons of fuel. Let's say we use 37 million ammonia and methanol, tons of methanol and ammonia. It's practically impossible to produce that much amount. That's why many governments around the world are establishing their own countermeasures because industry cannot follow that trend. That's why they're devising many rules and regulations. There's a huge gap between the regulation and what's taking place in the field. In Tokyo, in May, led by Asia, we have discussed ammonia-related regulations and how we are going to link that to the actual industry. If you're interested, then please visit the website. August Media Group has published a lot of coverage or articles on that, so please refer to that articles. 2 years ago, or it was 5 years ago, when I visited World Ocean Forum for the first time, I was requested to share my views on next generation fuel. In 2020, the hot topic was how to achieve net zero 2050. And at the time, we've mentioned that technology alone cannot solve this issue. And the fuel transition is a must toward that. This is the slide that I have used 5 years ago, and I have brought 4 pages here today. So the thing that I've mentioned 5 years ago was that the future fuel will be ammonia. However, for the past 5 years, many governments, research institutes, and industry focused on hydrogen. But as you know, the conclusion is that we should go back to ammonia. The reason behind that is because, as mentioned in the previous slide, ammonia and methanol production is so small compared to what's needed. The hydrogen generation volume is far less than even ammonia and methanol. And as mentioned, there are certain conditions for the vessel fuel, and we need a large amount of fuels to operate a vessel. To use it for the maritime industry, we need a vast amount of fuel generation, but hydrogen is being created in less volume than methanol and ammonia. That's why we're turning back to ammonia and methanol. So again, ammonia will be the future. Even in 5 years ago, we had reached certain consensus. Shipping companies and shipyards reached an agreement at the time, so we have done in-depth research. Engine designers, engine suppliers were studying ammonia because they had to reduce the pollutants being created by their engine. As you can see from the bottom left, these are the research results. In case of AVL, which I have worked in the past, there were around 7,000 researchers within AVL. And the researchers studied the source technology that goes into ammonia vessel and provided that to the institutions or companies that need those source material analysis. Again, I've brought the slides from 5 years ago as we are turning our eyes back to ammonia. This is the spectrum that includes upstream and downstream and what kind of industry is needed to have ammonia vessel. I'm not going to cover this in detail, but as you can see, there's MOL, NYK. They use ammonia vessel in different types, and they have different vessel operation depending on the vessel type. So these two companies are at the frontier. This slide is because, as the title is, the advanced technology includes the topic of advanced technology. I brought this slide. As mentioned, thousands of researchers have studied the next generation fuel, and we have provided that material to the company and institutions, and they use the research material to design their ship and design their engine. When we industrialize that source technology, this is the scenario that we need to go through. And then on the slide, you can see that conventional fuel is toxic and has some issues with safety, but the number one issue that we need to solve is safety. And as mentioned, this fuel is stored in a cryogenic environment, so we need to guarantee safety first. To guarantee safety, the first thing that we need to do is to detect. And first, we need to detect, measure, and analyze the amount. And then the next step is to train the personnel who will have to handle the fuel, because the existing personnel are so familiar to conventional fuel. Therefore, we need a training equipment for them. Through the source technology research, we have developed such equipment and training material. As I have time constraint, I'm not going to cover this in detail. But if you are interested in this, and I know that there are many online participants and young entrepreneurs, so if you need any material, I'll give it to you, so please contact me. This is related to ammonia production. And we are doing it already, but so far there was some price issue. In rural area, we use a lot of fertilizer, and ammonia can be made using fertilizer. But when we are trying to use ammonia as a vessel fuel, unlike fertilizer, we need to produce in different way. Japan, which is close to Korea, it has advanced technology in ammonia production. They have ammonia production value chain and has already made ecosystem just like bottom left. In case of Mitsubishi Group produce engine and vessel. They have shipyard and has many source technology. Therefore, compared to other companies or other shipyards, they understand the technology or what's needed quickly than others. For distant vessel operation, they have around 80,000 vessels that can operate to deep sea or distant waters. And most of the vessels for deep sea travel, they will retrofit. And when they retrofit the vessel, they need to compromise something or optimize something. But it's difficult to entirely change that. So for retrofit, they need to partly transform it. And some need to be captured through carbon, or some other will have to be captured using energy recovery system to recycle the steam or heat. Therefore, we need to protect the modular design of the vessel, but instead, we can use small modular equipment to produce ammonia, onboard it, and then onboard it to the ship. Then we can have a waste heat circulation system. This is the method that's being used by Mitsubishi, and they're quickly applying this technology to their conventional vessel. I think Korea needs to benchmark that. This is the table that I've compared the fuel type and characteristics, and later on you can see this slide. And ammonia, when it reaches 20 to 50 ppm, people will be able to notice because of the smell. Therefore, it is really fatal. So for marine engineering, we have two major companies, Epilogue and WinGD. They are developing ammonia engine. They have tested that and started commercial operation for their engine. And what's on the slide is, let's say, if we use those next generation fuel, and when that is stored in ports or in the vessel, what kind of state it will be. And most of these technologies or these methods have been commercialized. For medium and small companies in Korea, I guess you must pay attention to this. I think this technology is still premature. The technology should be upgraded and need to be commercialized in an advanced stage. This is related to bunkering. We have done ammonia bunkering. We have tested that. So if you search for the keyword ammonia bunkering ship to ship, you will be able to find many materials related to that. And this is just one case. It's not just an observation. Singapore decided to acknowledge the bunkering technology, and we are going to consider this to reflect into the rule. This is ship-to-ship bunkering. This was done by Mitsubishi OSK. And many other companies owned by independent owner. And they made or established Global Center for Maritime Decarbonization in Singapore. Mitsui OSK joined hands with the center to do ship-to-ship bunkering of ammonia. They have tested fueling and discharging of the fuel. So this is the world's first ammonia vessel. Again, this was shown in my first slide. This is liquefied ammonia carrier. 4 ports. I have studied 4 ports, and I have keeping my close eye on 4 ports. Lithuania is a major hub port of the Baltic Ocean. They have hydrogen ecosystem at the port. Even though the size is not that big, they can generate hydrogen, and it is the first time in the world to have that kind of infrastructure at the port. So I think we need to keep close eye on to that. For the vessel to operate commercial journey using ammonia, it needs ammonia storage system, and Germany is doing that to have ammonia storage tank. And Ulsan, I have covered the characteristics of the next generation fuel, for example, toxicity, and to process that, we need to have technology. We have Gas Safety Act in many different countries. But to have that next generation fuel at the port, it is difficult to commercialize within the Gas Safety Act environment. So the government has deregularized or eased the regulation for Ulsan. So let me conclude now. Maritime transport has no other option because maritime transport take on a large volume of cargo, so it will not go away. To achieve IMO 2050 GHG emission goal, technology alone cannot solve this or achieve this, so there should be a help from net zero or zero carbon fuel. And our practical choice will be ammonia. For that, detection, monitoring, cryogenic technology is needed, and storage facilities and logistics system technology should be developed. That's the final message I would like to pass on to you. Thank you for your attention.
다시 한번
Thank you, Mr. Lee, for your wonderful presentation. Please give him a big round of applause again. As the IMO announced the decarbonization and net zero, many are preparing for that. Many think that the ammonia and the hydrogen is the answer, faster answers. But as you saw today, ammonia and hydrogen and SMR needs the maturity of the technology and the safety and also the efficiency. So we still have a long way to go. Thank you for your presentation. Next, Professor Jung-ik Lee of KAIST will give the presentation under the topic of like a future promising fuel, the advanced the fuel, which is SMR application to the marine industry and the potential challenges. And he is a KAIST professor and the next generation member of the Academy of Science and Technology. And he's conducting the research on next generation nuclear power plants, such as marine nuclear power plants and SMR. Please welcome him with a big round of applause. Good morning, everyone. I am Jung-ik Lee from the Department of Nuclear and the Quantum Engineering of the KAIST. Today, I want to explain about the SMR. Last year, I was requested to deliver the similar presentation, but I wanted to give some different perspective. So last year, I talked about the introduction of the SMR technologies, but today, I want to focus more on SMR and SMR application to marine industry. And also I want to give you food for thoughts, like challenges and the risks. So the previous speakers talked about the IMO direction and the importance of the carbon-free net zero. So maybe I will go a little quicker in the first part, and then I will more focus on the SMR application to the marine industry in later pages. So this is all already mentioned by the previous speaker, so I don't need to talk about this. So the across the world, the net zero, carbon net zero is the buzzword, and now we can consider the various technologies. But when we think about the life cycle assessment, the nuclear power generate the least amount of the carbon. During the operation, the other technologies do not emit the carbon, but during the manufacturing, it can emit the carbon. So considering the life cycle of the total propensity, the nuclear power can be the option for the carbon net zero. So, of course, we know that is carbon-free, but we also need to consider the economic viability. And the nuclear-powered ship is not researched that much. So this Japanese paper is mostly referenced thesis papers, and the one company, the EMSA, assess the sensitivity of the economic viabilities about this. So this is open source, so please refer to it, what kind of considerations and what kind of utilization you can have when you apply the nuclear power to the marine industry. This is a container ship. It shows the accumulated cost. So this economic assessment shows even with the conservative assessment, compared to BLSO, for the container ship, for the long-term operation, nuclear was much better. So this is a container ship, but it also can be applied to the LNG and the bulk carrier. You can see the much reduced the accumulated economic values compared to the VLSO for the bulk and the LNG carrier too. So let's think about the nuclear power. Previous speaker talked about it. The safety is always the first element we have to consider when we use the nuclear power. But even though the AI technologies is not safe yet, because we expected that within just a couple of years ago, we didn't expect the AI is much better than certain like a pro go and stop players, but now it proceeds and exceeds all those like capability than the human. Also, we had a wind shore much faster than before, but we didn't use the renewable energy because of high cost. But through the continuous technological breakthrough, we make this expensive cost affordable for us. So about the also nuclear power, people have percept of the unsafety, but we need to, if we develop the more safer technologies, it could be a safer. So what level of the safety we should guarantee to use nuclear power? I believe that that we need to prove that to the people, so that all this nuclear power can be safely used for the other industrial applications. But when there is a significant accident, it can have the radiation exposure to the people. So there's a limitation to build a nuclear power plant in any place. But the SMR can solve this kind of the concerns and safety issues based on the high-tech safety requirement. So compared to the large-scale reactor, the SMR is much safer, even in the case of the radiation emergency. So this nuclear power can access to the various market, not only the generation, but also the propulsion for the marine industry, and it can also apply to the iron mills or in the other industry. So if we can avoid the limitation of the siting, the nuclear energy can be used much often in the various industry. I believe that is the basic element we have to pursue. So just like AI, we didn't expect this technology is possible, but NuScale received the standard design approval from the U.S. regulatory. So we have a concept of EPZ, which is an environmental protective zone. in case of the radiation area, that is kind of evacuation zone range. So the original or the nuclear power plant's EPZ was a 10-mile range, but the SMR has the very small boundary of the EPZ. So if it means that if the Manhattan is qualified for the siting of the SMR, and then it means that even in case of the radiation emergency, people do not need to evacuate. That's what this EPZ, site boundary EPZ, means. So if we have such kind of safety requirements, we will not have the siting limitation. Then we can apply this SMR more often to the various applications. And for the nuclear power plant operation, the large-scale reactors needs a large amount of operators to operate the reactor. But if we build and operate more SMR, we don't need that many operators. So the new scale said that only 3 operators are needed for the 12 SMR operation. So they can control 12 SMRs at the same time, and that was approved by the US NRC. So this kind of high-tech technology is advancing. I believe that they already took the first step, I believe. There was a huge momentum for the nuclear technology. And so after these nuclear new-scale SMR, we see the various types of the SMR in the market. So I believe that the safety of the SMR is the most important element to enter into a market. But the weakest point of the SMR is the economy of scale. So due to this, the scale of the economy, they build the large reactor. But in order to have such kind of the economy of scale, the SMR should change into the equipment industry so that we can install the SMR just like a home appliance, like air conditioner. So we have to go for the minimal construction so that the factory make the SMR in advance, and they can deliver it like a turnkey. So I believe that will be the technological breakthrough for the SMR's advancement in the future. We have reactors based on the 3rd generation technology and the 4th generation technology. So the 3rd generation 3s are use water as a coolant, which is the same technology as a large reactor. But it means that they have a limitation of LWR, but also it means that it is a proven technology. And all the icebreaker and the nuclear power vessels are using the water as a coolant. So maybe this a water cooling technology will be the most imminent technology for the nuclear power vessels. But if generation 4 has a more safety requirement, safety safety features, so the water cooling reactor, and just the water cooling reactor can be adopted faster than the other technology, I believe, because it is already proven and it can be already safely applied to the vessels. So the U.S. also developed the water cooling and the sodium salt cooling, but there was some propulsion issue in the sodium, so that's why the water cooling was adopted for the U.S. Nuclear-powered ships. That's why we are using the water cooling reactor so far. But also Russia tried to use the lead cooling reactor. So this nuclear power has a long history of application in the marine industry, and I believe the next generation technology can be used in the marine industry, and also like a fast sodium melted the design is regarded as like a fifth generation, but there's no structure inside the reactors. The fuel itself react to the reactions, and it also become like a moderator and a coolant. So when we use the nuclear energy in the marine industry, solid fuel was the problem, but if we use the liquefied fuel, maybe refueling will be much easier, and the fast reactor has a characteristic to operate for long term without any refueling. So I believe that has an advantage too. So the MCFR can be an ideal application for the marine industry. So that's why many the shipbuilding companies are considering this MFSR. So nuclear fissions are used in the third generation and fourth generation, but the difference is the usage of the neutron after the fission. That is the biggest difference. The water cooling reactor has a high energy after fission. So just like the graph on the right, uranium-235 is not reacted well to generate the neutron. But for the better reaction of the neutron, we have to increase the concentration of the nuclear fuel, or we have to bring it to the better fission area. Water cooling reactor says like a neutron moderator, and we have to moderate the neutron so that we can make an environment for the good reaction with the uranium-235. That is the main character of the third generation reactor. So we are using the water as a moderator in this generation. And the number of neutrons is just usually 2 in the better environment. So you can see the ETA here. It shows a possibility of the neutron. Thermal neutrons are made in the low energy, and if we use the fast neutron, we will have the more neutron to have more functions. It can also regenerate the fuel. So in the fast reactor, we can have the long-term burn-up cycle. That is why these fast reactors are considered a lot. It is not just in the marine industry. Like a U.S. TerraPower tried to replace this MSFR, coal power plant with this SFR. So reactors are using the various types of the moderators and the materials. So we have the various options, and we have to consider the various aspects of each reactor type. So the PWR is a viable option for now. And also we have ATGR and SFR and MSR with all different kinds of a fluid and the fuels and the coolant and the moderator. So I believe that everybody is verifying which type of the reactor is most viable for now. So I just want to say that the application of nuclear power has been long in the submarine and the USS Nautilus and the USS Enterprise and the Virginia. So but the commercialization was limited. We have 4 commercialized nuclear powered ship, but most of the Western nuclear powered ship has a low economic value. Because it was more like a research type vessels, research type reactor. So it didn't have the good performance. So even though there was the nuclear powered ship technology, but we didn't use it that much. So when we see this nuclear reactor, the volume and the mass is very big. So when we design the next generation nuclear power ship, we have to think how we can make it smaller and more compact. The biggest part of the weight usually in the reactor is the radiation shielding materials. The reactor system weighs just 30% of the total weight, but the rest of them are mostly for shielding. But the shielding is designated or defined by the radiation regulation. But we didn't have enough justification for the radiation protection. And that old practices has been continued up to now. That's why it is little out of date, I believe. Recently in 2025, Trump signed the famous act, and the linear model in the radiation was changed according to the act of the Trump. So as we have a changing the nuclear regulation environment, maybe we will have a different situation later. So we have a background radiation and the radiation exposure to this kind of the facility or equipment. But the current regulation is as low as possible. So that is based on the linear non-thread model. So this LNT model was the main cause for the high weight of the shielding. So these regulations, radiation exposure regulation, also should be considered for this nuclear power ship. Many people are following the ICRP recommendation, but the USA are following different rules. So we need to have like a harmonization of the regulations too. So due to the time constraints, I cannot give you the full explanation of the IMO codes, but now we have a radiation protection based on like a regulation made in 1950s or 60s. So as we have the changing regulation environment, we also have to find a way to comply and innovate the regulations for all this kind of the nuclear power ship. But we didn't have like a risk-based assessment in the past. So we have to assess the risks of this nuclear power by comparing it to the original and the conventional vessels. I believe that would be meaningful. We also had a research about the risks of the diesel-powered ship. The diesel-powered ship also generate a lot of carcinogen. So we have to consider the regulation for the radiation exposure of the nuclear power ship with this kind of the diesel-powered ship regulation, because actually the risk could be like a similar or the lower. So we have to have a differentiated, a graded approach for the radiation exposures for each workers in nuclear power plant or in the aerospace industry. So we can maintain the risk on the same level, but we can differentiate the regulation depending on the radio exposures to those works and the workers. So that's how we can solve all these radiation problems more logically. So we need to have a higher understanding about the radiation to make the reasonable regulation for this nuclear power ship. So we have to improve the risk, and we have to regulate the holistic risk. So the annual risk is not a desirable way to have a regulation. So we calculate that based on the NS Savannah. If we change our regulation, we can reduce the weight of the nuclear power ship by 10 to 15%. So we have to think about that. So far, we had a lot of discussions and the consideration so far, but we didn't have any platform to report it. But now we have the NEMO, Nuclear Energy Maritime Organization. So maybe this kind of organization can work for us more actively, so that the potential of the SMR can be utilized for the marine industry, I believe. I believe that Korea is taking the advantageous edge in terms of the development of the nuclear power ship, because construction of nuclear power plant is expensive. because others, like French or the U.S. companies, cannot deliver the reactor on time. But Korea's nuclear power plant is on time and on budget. So if we build a ship with the SMR, I believe that the Korea will be the number one in making the nuclear power ship. So for the nuclear industry and for the marine industry, like adoption of this nuclear power ship should be made in Korea for the first time, I believe. Thank you for listening.
예, 이정익 교수님 장시한
Thank you, Professor Lee Jong-ik. Whenever we talk about SMR, people think about nuclear power plant, but SMR will play a major role in the future fuel as it is net zero and has a lot of potential. Thank you for covering SMR technology. There are some conditions and requirements such as safety, but if we prepare from now on, I guess SMR can be applied to maritime as well. Once again, please give him a big round of applause. Next, the fourth speaker is Mr. Lee Tae-jin, Executive Vice President of Hyundai Heavy Industries, CDO and CTO. Mr. Lee has been taking on the digitalization of maritime in HD Hyundai. Today, the topic of the presentation is Innovation Strategies for Advanced Ocean Mobility Technology and Global Competitiveness in an Era of Digital Transformation. As mentioned, global maritime is going digital. And let's see how maritime industry can achieve digital transformation. So far, we have achieved digitalization in manufacturing and ship operation. And this technology will further be applied in a more big scale. Let me invite Mr. Lee Tae-jin. Nice to meet you all. I am Lee Tae-jin. Mr. An, who is our moderator, requested me to give presentation. But as World Ocean Forum is a big and major forum, and I thought a lot on what to present. And when Mr. An was the president of my company, he emphasized that the future of maritime will be decarbonization and digitalization. And he always mentioned that several times. So to lead the digitalization of the maritime industry, he encouraged me to take on the role. So thank you for giving me the opportunity to cover digitalization aspect. So the title is ambitious. How shipbuilding industry can be more prepared for maritime business, future maritime business. So this is the agenda that I'll cover today. Let me introduce Hyundai Smart Ship technology and solutions that goes into that. And the future of maritime business, because in the afternoon, we are going to cover that subject. Recently, I know that many participants are experts in this field and have deep knowledge on this, and I guess you will know what's going on in the maritime business field. So when I give lecture or presentation to other people on this issue, and I always mention this point as an icebreaker. So I always mention that if you bought a stock in the maritime company last year, then you may have earned a lot, because the Korean shipbuilding industry is gaining a lot of attention these days. And internally, we think that we are enjoying a good chance. And there can be two reasons. First, today, we are talking a lot about decarbonization and net zero carbon emission. And for shipbuilding industry, it is a great challenge, but at the same time, great opportunity. So far, shipbuilding industry went through different cycles. There were ups and downs in the market. And many people thought that that pattern will sustain. But we think differently. Related to decarbonization, vessels across the world will make an attempt to go net zero, and we are taking the first step toward that. Just like the previous speakers, ammonia and SMR, the fuels will change, and vessels will have to adapt to that changes. That is a challenge and an opportunity for the shipbuilders like us. Another aspect is support to the U.S., and I think that's another great opportunity that we can enjoy. Today's topic includes MASCA. The role that can play within the U.S. revitalization of MASCA or revitalization of shipbuilding industry, I think Korea can play a huge role. But let's see the current situation. But the thing that I would like to mention is that there's not only green signal but red signal because of the talent shortage. In the shipbuilding industry, those who worked in this field, when the market wasn't good, they left the industry and they didn't come back. There's a shortage of talent, so we had to invite foreign workers to the field. As you know, shipbuilding industry, the work should be done outside in hot summer days and in the cold winter days, inside the vessel or at the port, at the shipyard. So it is a really difficult job. If we cannot address this talent shortage issue or the working environment issue, then the young talent will not come back to the industry. And second, as you well know, we consume a lot of steel plate, steels, and consume a lot of advanced solutions, and the price is going up. Therefore, cost is going up, the price is going up. Therefore, there is an ups and downs in competitiveness. And talent shortage issue impact the people cost. And increasing people cost is a huge burden for us because we need to explore the opportunities posed by decarbonization. So we are at a crossroad where we are going to enjoy this chance or not. For 10 years ago, we have suggested the idea from 2020 to 2030. We embarked on a plan to make a smart shipyard and set the direction for the future shipyard. The thing that we consider is to digitalize the shipyard so that the talent and the working environment can adapt to the future change. Starting from 2020 to 2030, we had set up 10-year plan called Future of Shipyard Plan. Future of Shipyard, when we started that plan, we asked ourselves what will be the future of this industry in 2030. So that was our bold goal. With a 3-year plan first, starting from 2020, the first thing that we did was, as you know, it has been 50 years since we first made the shipyard. And so far, we have worked in analog way. And for the first 3 years, we tried to digitalize all the assets of the ports, a shipyard. And we checked all the data using computer, and that's the goal that we had at the time, to make the shipyard digitally visible. Many parts of the shipyard has turned digital, and we've made a lot of effort for that. We cannot say that we have turned that in 100% digital, but as you know, many equipment and working method had been transformed to digital way. And the second phase is something that we have started to do from last year. It's intelligent and connected shipyard. Through digitalization, we have collected data. And by linking data, we can optimize the operation at the shipyard. And that's the vision that we have for intelligent and connected shipyard. If so, then we will be able to realize our dream, which is to use digital data from the shipyard to let each department use this data and connect all the different departments of the shipyard. And third is autonomous and intelligent shipyard, and this will be completed by 2030. Autonomous shipyard means that we are going to use humanoid robots, and AI monitors the operation and coaches operation, as well as making decision. When we complete autonomous and intelligent shipyard, so far for the past 10 years, we have discussed how we will transform this industry, and at the beginning we have envisioned a future where humanoids work and human monitors. So that was a big picture that we had when starting this project with our industry veterans, and also we set the goal. But in the process of implementing the goal, AI technology stepped in, and we realized that the dream that we had at first has some tools to realize. So we have a very positive view that we will be able to achieve that. As mentioned, by 2030, we are going to make intelligent and autonomous shipyard. Likewise, the vessels are moving in that way. Our vessels have 10-year plan. Vessel digitalization is being progressed. So from 2020 till 2025, we have smart ship plan using IoT, which was the huge technology at the time. We could monitor the vessel and optimize the vessel route. So that's the plan that we have for the 5-year. And now we are advancing that into intelligent ship. We have done a lot of demonstration projects to have autonomous ship. We are doing a research on that as well. Once we complete the technology, just like the shipyard is shooting for a smart shipyard by 2030, the vessel will also become autonomous vessel by 2030. So related to smart ship, the part that I'm going to explain to you in detail is this. 10 years ago or 15 years ago, we have started to talk about fourth industrial revolution. The technology that has been highlighted for that was IoT. Applying IoT for the industry so that we can connect sensor, collect data, and make big data so that we can utilize the big data. So that was the picture that we have for fourth industrial revolution. So far for the past 10 to 15 years, that was the definition of Industry 4.0. And against that backdrop, we consider how we can use IoT for the vessel and shipyard. Vessels, just like manufacturing plant. For the manufacturing plant, for Industry 4.0, we focus our efforts on smart factory. Just like that, we started to consider how to make smart ship. To make smart ship, just like smart factory, we need to make the equipment within the vessel, for example, engines and sensors. All the data coming from the equipment and sensor need to be collected and made it into big data. Just like a smart factory in the manufacturing plant, we can make a smart ship. That was the concept that we had, and we discussed how to realize that. There can be many ways to achieve that. But for Korean shipbuilding industry, what was important at the time was to make a ship data platform, just like what's on the right side. HD, Samsung Heavy Industry, and Daewoo, they turned into Hanwha Ocean, 3 companies, and other medium and small size shipbuilders and shipping companies gathered to make a ship data platform. Thanks to the support of the government agency and research institutions, we started to do vessel data platform, which is Blue One platform. Using Blue One platform, we could standardize protocol of the vessel data so that we can apply the same protocol for the vessel equipment company, gather the data from them and from the industry. If so, that using the vessel data, we thought that we can utilize in an infinite way. That was our project Blue One, and I think that was the first step towards making a smart ship. I think this slide covers what I have explained so well. Just like on the left side, there are many devices and equipment, and they have sensors. And all the data that comes from the vessel is collected in the platform and is stored in the platform. And we have made the database so that we can gather it. And what's written in the green is solution layers. For example, voyage management or vessel control, cargo management are provided as solution layers. When making the platform, the management of HD had a lot of concern because 3 companies, Samsung, Hyundai, and Hanwha, are in competition. But if we make a common platform, we won't be able to differentiate our competitiveness. So management had a lot of concerns because of the business. But what we explained to them to persuade is this point. Making a platform is like a Windows OS. Computers need to have an operating system so that to operate, and whether the company will use MS Word or HWP or PowerPoint, it depends on the decision of the company. So the solutions will be the differentiating points, and companies can still compete with one another by developing the solutions. After that persuasion, HD started to use ISS, Intelligent Smart Ship Solution. That's the solutions that we have incorporated into the platform to differentiate ourselves. So we have equipped our vessel with HD ISS, and now they are in operation. While doing so, vessels can use HD ISS, and many equipment and devices produce the data. And for the crew members and captain can use the data to do their work on journey. There is a solution that helps their journey, and then some data is connected to the satellite so that we can do fleet management. Vessel owners can use that fleet management service to see how the vessel is operating in real time. And that is underway. This is an onshore-offshore integrated solution. So these are the projects that we are leading. We have 3 different categories for our solution that are being provided to our clients. First is related to economical voyage. For that, the first solution that we provide is route optimization solution. You know there are many different sea routes at sea. Then the shipping company will have to decide what kind of route they will have to choose to decarbonize or enhance the fuel efficiency of the vessel. We provide the solution on board a vessel. And depending on the cargo weight, the trim needs to be adjusted, and the solution gives the guidance on how much trim they need. And second is safety-related solution. When it comes to rolling and controlling, we can use many different sensors on board a vessel. We have a lot of engineering knowledge within Hyundai, so we have incorporated all those knowledge to the solutions to provide anti-rolling solution. Also, when there is a bad weather forecast, we suggest another route to detour to prevent rolling. When we have the cargo weight, we know that the operationality or operationability is impacted according to the weight of the cargo. Therefore, we give that data to the captain or crew members so that they can optimize their journey. So when you drive, you use the camera sensors on the vehicle. You don't look back to park your car. Just like that, if the crew members and captain can use that solution, they can use the dashboard to get the data they want. They can see the menus they want, they can click it and get the data that they need. Another thing is that all the performance related to the vessel is shown on the dashboard. And on top of that, what's in the middle is the onboard platform that I have explained so far, and data produced by onboard platform is sent to the satellite, and so that we can provide onshore services. For example, we can do vessel diagnosis, monitoring, and performance analysis. And on that platform, there are some elements related to AI. We are doing that work currently. On the ISS platform, we have high CBM, condition-based monitoring system. So we can check the status of the equipment on board our ship to gain an insight related to maintenance and repair. So that's high CBM. And another solution we have is HINAS, Navigation Assistant System. HINAS started as a navigation assistance system, but as we are moving toward autonomous vehicle, the HINAS solution will be very important to that. And another one is AI-based camera. Just like manufacturing plant has CCTV to detect any dangerous situation, we can do AI monitoring incorporated into our system. As mentioned, we have data solution, and we are equipping it with many different AI solutions, and AI solution is one of that. Let me show you the video clip on our solution.
CCTV를 통해
Using the CCTV on board a vessel, AI monitors and guarantees safety of the crew member. When the crew member falls, then AI can detect the situation and gives relevant information. So seafarers can work safely on board. So in the process of the journey, the vessel condition is being monitored in real time. When the engine temperature goes up, then the dashboard gives a warning, and onshore remote operator can see that situation and gives an advice. Thanks to that, we can do safe operation. So in the journey, engine and equipment are getting a lot of stress and becoming fatigued, but no problem because we can do predictive maintenance using our remote operation center. And the parts that will be needed for the repair will be able to be secure from the port because we have early warning. Vessel energy, fuel consumption can be monitored as well so that the vessel operator can use less oil to reap maximum efficiency and can reduce carbon emission by 50%. So I hope you understood our technology through the video. We have Ocean AI. So data produced by the vessel and the oceanized AI solution that we have, we use data from the vessel to give an advice on optimum or optimized route and optimized route operation. We have CII value and can calculate the CII value if the vessel operates in the current way, calculate the index, and predict the CII number or indicator by the end of the year. So we can make suggestion on how to reduce the CII by the end of the year. AI analyzes the CII and gives an advice to reduce the CII index. This is the video related to oceanize. I believe the future will be like so. When there's a hurricane on the journey, then the system can give an advice to detour. And when the vessel is in operation, then it can calculate the time until the destination. So if the port is congested, then the system can give an advice to go slow. Or when the route is congested, it can give further advice to take on more cargo till the destination port. I think this will be the future of the vessel. So this is my conclusion. So for future of maritime business, we believe there are 4 big keywords. So this slide shows that 4 keywords. 3 years ago, Hyundai Heavy Industry opened up a shipyard in Ulsan and changed our name to Hyundai Korea Shipbuilding and announced a new vision at the time. So this is the vision and the 4 keywords for the new future of our company that include maritime mobility, maritime digital solution, future of shipyard, and marine energy value chain. In fact, many that I have mentioned are related to those 4 keywords. Related to shipbuilding industry, Hyundai Heavy Industry is envisioning the future, and I think we need to go together to share the challenges that we have for the future, and we can find a shortcut toward the future. Today, we have mentioned a lot about decarbonization, whether it be that or related to automation. The future of marine mobility, for example, the fuel, we have that project for the future. And just like I've mentioned, marine digital solutions. When we make vessel, we don't just give a product, which is the ship, to the client. Going beyond that, we are providing solutions to them. And HG wants to become a solution provider at the same time. That's why we have the vision of marine digital solution as one part of our business to tap into a new business area of the maritime. And third is future of shipyard. As mentioned in my introductory part, if the shipyard doesn't make vessel, there will be no future for the shipping industry. For us to make more ships, then the shipyards need to become smart and need to complete the vision that we have for the future. That's our mission again. And all these are connected into marine value chain. And I guess participants here are a player of our value chain. So we need to gather wisdom so that we can facilitate the marine value chain, and Hyundai will contribute to that. This is my final comment. HD Hyundai thinks that ocean transformation is an important keyword. How we are going to take ocean and transform. HC Hyundai will lead the future as a future builder. We will meet you again in the afternoon panel discussion, and this concludes my presentation. Thank you.
오늘 액티브한 발표.
Thank you for your active presentation, Mr. Lee. Please give him a big round of applause again. The reason why I invited him is that we wanted to share this ocean transformation all those items he talked about can be confidential, but you see here we have a like extensive range of the ocean transformation. Many people ask me, so if we have that kind of ocean transformation or the ocean mobility, what should we do? They ask. Like, is there any job they can do? But we, like all the experts who have more than 20 years of experience, they are controlling and they monitoring all those systems. So all the veteran and the skilled people are working for this automation and the transformation. So I believe that we will have a huge change after the ocean transformation. Once again, I thank the Mr. Lee for your insightful presentation. So this is the last presentation in this session, and we will invite the Mr. Stavros Hatzigrigouris, the former president of the Marine Gas. He will talk about the global shipping and shipbuilding and the shipping industry in the age of uncertainty, macroeconomic outlook, and strategic response. So, the Mr. Hatzigrigouris is the prestigious expert in the shipbuilding, and for several decades, he was the chairman of the committee. And also, he was in charge of like 160 vessels shipbuilding in Korea. He is very respected, a prestigious man. So it was very difficult to invite him to this session. He was supposed to be here, but he is very busy man, and he will join us online. Maybe this is like a sleeping time for you, but you are joining here with us. So I really thank you, and please welcome him with a big round of applause. Thank you. Can you hear us? Okay. Yes, I can hear you very well, and then you can start your presentation.
Screen?
Yes, we can see your screen. Thank you.
I think it's an honor for me to receive the invitation to be the keynote speaker. As Mr. An said, and I thank him very much for what he said, my background is engineering, and I don't feel very comfortable to speak, to try to predict the market. But I have to do it, and I will try to be brief. I don't think my presentation will be as detailed as the previous presentations, which were really nice presentations and created a lot of questions that have to be asked, to be replied as soon as possible. So Mr. An said that I've done 160 ships in Korea. Actually, it's 169, and I am not in Busan. The reason for this is that yesterday Zodiac signed a contract with Samsung and Petro Vietnam to build 3+1 Suezmaxes in Vietnam. I think it's going to be an experience, but I feel that with the support of Korean shipbuilding technology, this new Vietnam yard will be successful. This is some photographs from past experience and past record in Korea. What you can see on the left-hand side is my first project in Korea, 1988. We brought in Korea from Greece a tanker that was damaged in Greece, and we did a big repair in Mipo. A nice experience. World seaborne trade. As you can see in the left-hand slide, it's an estimation basically, it is what has been happening until 2025. As you can see, the world seaborne trade is increasing. We have about 80% of the world seaborne trade carried out by ship. I think we will see the seaborne trade increasing until 2050 if we put 2050 as the horizon. And the main reason for this is the increase of the population of Greece. In Europe, the population is not increasing, but we have a big increase in South America, and everybody is expecting that we will see the same thing in Africa. On the right-hand side, what you can see is the estimated billion-ton miles. I'm not sure that these predictions, which I have taken from the United Nations, are accurate, and the main reason for this is number one, the globalization is on the decline. There are many countries with the US leading that and Europe that they want the industry to return to their countries near the consumer, and of course this will reduce seaborne trade. I think that a second danger for seaborne trade is the robotization of production. If a robot is to be used to produce merchandise, it will be approximately the same cost in Europe or the US, and with the cost in China. The big difference between China and the West is the cost of energy. The cost of energy is subsidized by China, but it is not subsidized by the Western countries. As I said, it's 80%, approximately 80% of the seaborne trade is carried by ships. In 2024, we had an increase of 2.2%, 2025, 0.5%. And the reason for this reduction in growth that we see in 2025, and we may see it continued for the next year at least, is what is happening in the commercial relationships between the US and China and several other countries. It is tariffs, and it's volatility and demand uncertainty. At the same time, we have some routes that have been restricted, but these may be good for shipping because the trading route is longer. And we have problems, as you know, in the Red Sea, in the Black Sea, in the Taiwan Straits, and the insurance costs go up, and the fuel consumption is also going up. I think this is one of the reasons, as it was mentioned by previous speakers, that KK Lee in particular, that we don't see emissions from the shipping industry being reduced. I think what you see in these two tables is the tariffs. Some people they call it tariffs. I call them penalties that the US have said that they will apply on Chinese vessels built or owned by Chinese companies. And the second table is what China will apply on United States related vessels. As you know, the US flag is not a popular flag, but what is popular is shipping companies being stock listed in the US stock markets, and China is considering with various tricks that these US vessels, these vessels are considered as US owned. As you can see from the table, the Chinese fees are stricter for most of the types of the vessels than what the US are applying at this moment. The problem that we have here is that we have seen the leadership of the United States coming with certain measures that will promote the negotiation between them and the interested countries, and a few days later we have a complete change in the US policy that is followed by the policy of the countries that trade with the US. This is uncertainty, and this is not helping world trade. Talking about shipbuilding, you can see in this graph how the shipbuilding has developed since the beginning of the 20th century. Have a look at the blue color, the deep blue color, which is the United Kingdom. You can see that the United Kingdom was delivering almost more than 55% of the world fleet in the 50s, 60s, and this was reduced in the 1990s to zero. On the other hand, we see that other countries, especially Japan, had a big share of the shipbuilding market. Korea had a big, but now this has dropped to less than 10%. Korea's share is being reduced, and of course the shipbuilding capacity has been reduced. And on the other hand, we see that despite the general reduction of shipbuilding capacity and the closure of several Chinese yards, the Chinese production is more or less steady with the trend to increase. Looking at the new building order book in 2024, you can see that China is dominating the market, as I said. Korea is second, and the Japan production is being reduced, concentrating most of the times for bulk carriers. What is interesting is that South Korea, it is very evident they don't care about bulk carriers, but bulk carriers, in my view, constitute a kind of steady market. Threatening for the Korean shipbuilding is the fact that we now have 5 or 6 Chinese yards that are producing LNG ships, and you can see that their order book at the end of 24, and it has been no big change in 2025 because the LNG market is not helping, and the number of LNG vessels ordered until today in 2025 is it's about 15. But again, the fact that we have a large number of Chinese yards producing LNG vessels is threatening. What this is also showing is that the Chinese, and especially the design institutes, have managed to catch up with the LNG technology, which was not an issue in the past. These are comments that I have already made. China is focusing on production. Korea is focusing on high added value ships. I had a discussion with one of the Korean yards, Samsung in particular, yesterday. They were saying that they are not interested to build even tankers in Korea at this moment. They are focusing on LNG and big container ships, and building, as I said before, tankers in other countries. Samsung, they have, I think, a contract for 8 ships with Paxocean in China, and now 4 ships in Vietnam. The Japanese yards, they focus, it's not right to say, as I'm saying in the slide, new technology, but they have an established efficient design base, and they keep producing ships with high efficiency. But if you compare what you get in Korea with what you get in Japan, I could say that Korea is value for money. Japan is very, very difficult to cooperate, to work with them. We see consolidation in the shipbuilding market. And we have seen also some of the big Chinese yards, ex-Hengli, ex-STX, which is was a huge yard, and they have increased the capacity now, coming back into the market. What we see in shipbuilding, we see rising prices, which is not bad for the shipyard. And personally, what I support is that the shipyard should make a profit. It's not nice to work with in an industry that is losing money. And I think the period, say, between 2012 and 2018 was not a good example for the Korean shipbuilding. We see automation and digitalization increasing, as was mentioned by the previous speaker from HD. We see what is happening in the US, which is not helping, and we expect, of course, as I said before, 80% of the world trade is done by shipping, and this will not be changed in the near future. New types of ship, you can see what is happening now, for example, with liquid CO2 carriers. Only 4 ships have been contracted and are under construction in Korea. The first one will be delivered in in January next year. But you can also see that there is competition from China. Of course, the size of the ships that China can build is smaller than one Korea is building today. Again, order book in million compensated gross tons and in number of ships. In the previous slide, you can see what are the order books for the time being until 2028. And from information that I get from a number of yards, there are still only few berths for 2028 that have not been sold. Green vessels was discussed by the previous speakers. We have a number of regulations that have come into force starting from 2016-17. We have the IMO regulations that unfortunately the negotiations failed 2 weeks ago. We have the CII, we have the UETS, we have the Fuel EU, and recently, as you can see in the last bullet point, we have African countries like Gabon and Djibouti applying their own ETS, and there was also an announcement from 14 African countries that were saying that one way or the other they will apply their own ETS. What problem is this creating? Ship owners or ship managers or the cargo owners, and at the end of the day the consumers, they will have to pay more than one time for the same problem, for emissions. What you can see here is how the EU ETS money that is collected because of the EU ETS scheme, how the situation is developing from 2016 to 2024. We are talking now about 79 billion euros. Dual fuel new buildings. LNG is the fuel that is dominating the market today. At a certain point, it was 50-50 with methanol, but now methanol has retreated. And as you all know, grey methanol is not improving emissions, and green methanol may be too expensive. What was mentioned by KK was ammonia. I agree with him that ammonia will be the cheapest fuel, but we have to solve the toxicity issue. And recently, the first WinGD engine that was tested in Korea for Exmar have publicly said that ammonia is not coming without problems. But of course, this is true for all new technologies. And I think that ship owners who are ordering new technology ships should understand that we cannot be 100%. We don't know all the problems of new technology at the moment an engine is tested or a ship is delivered. Fuel ready, there are class notations related to fuel ready. I think this is a kind of gimmick. We had in Maran VLCC's fuel ready, and the cost of making a vessel, a VLCC LNG ready, was about $200,000, so Dean knows it. When the cost of, at that time, when the cost of delivering a DF VLCC was 14, 15, 16 million. Retrofit market, based on what we have seen from IMO, the failure of the negotiations in IMO, I don't believe that many owners will proceed with retrofit to methanol or to LNG. The cost is high, and on top of the cost, you have to add the off-hire period that will be needed to do the retrofit. Nuclear and SMR reactor, the subject was covered in a very good way from the previous speaker. IMO MEPC, this is what the IMO was trying to produce. What you can see is that most of the conventional fuels, the fossil fuels, were penalized with the amount of money that was requested by the operators of a Kamsarmax vessel consuming 20 tons per day is shown in this graph. Beyond 2034, as per the IMO proposal that was not voted during MEPC 83, was going to be a kind of prohibitive. This is how the relationship between the cargo value and the fuel cost to cargo value was going to be to develop according to the IMO. You could see that the fuel cost, although we complained, was not going to be a high percentage of the cargo value. You can see on the last column the total increase of the cost of the cargo, including the penalties, was not going to be more than 1%. But there was a big noise about this. What happened in IMO 2 weeks ago? The member states could not reach an agreement, and the decision has been postponed for 1 year. Are we going to have a decision after 1 year? I will refer to this on my last slides. The vote that the people that voted for the postponement were not the people, the flag states were 57. 49 countries said let's finish now, and a large number abstained. What was interesting to see is that although the EU normally votes as a bloc, the 27 countries, this time Greece, which has about 60% of the European fleet, and Cyprus pushed the EU and managed to get the approval to abstain from the vote. The key points that were discussed was if the acceptance of the IMO decisions was going to be tacit. Tacit means that if no states object in writing whatever is discussed in IMO within a certain period, the IMO requirements will be considered as final. Explicit means that the countries should put a vote with their name, and then it is decided if the legislation will pass or not. This is explaining it. And this procedure is normally used for the Marpol amendments that are being discussed more or less on a continuous basis. Then, please read this statement. This is the statement that turned the wind in IMO. Mr. Trump or King Trump, I don't know. He said very, very openly that the US will not tolerate increased prices on American consumers or the creation of a green new scam bureaucracy. What he threatened actually was that for vessels arriving in the US burning an expensive fuel, there will be penalties so that the cost is not passed to the US consumer. This, I think, will make, if this policy is continued next year, I think it will make the life of IMO very difficult. And what I see for the next MEPC, the postponed MEPC, there is only one MEPC in scheduled for April, during which new measures can be discussed, but the time will not be enough to discuss these measures during the extraordinary MEPC. If the US follow their own, what they have said up to now, and taking into account that they can influence a lot of countries to follow them, personally, I don't believe that we will have an agreement next year. And if there is no agreement next year, maybe IMO will decide on the factors that will affect and maybe determine penalties for the different fuels, but then it will be left to the open market, to the free market, to decide what engines, what technology will be used for the ships to be delivered going to 2030, 2035. That's all from my side. I tried to keep it short, and thank you very much for your attendance. And sorry that I had to do this keynote speech at the end of the session and not in the beginning. Thank you very much.
다시 한번
Once again, Mr. Hatzi Grigoris for making this presentation even in that early morning. So global market share and the IMO's decision can impact significantly on the Korean shipbuilding industry. So I'd like to thank your insight and opinions once again. Please give him a big round of applause. Thank you very much. So with this, we can conclude the presentation session of the shipbuilding session. So we will see you again later.
수고해주신 모든 분들과 또 오늘
Thank you, all participants and the speakers and the moderator, Mr. Kwang-won An, for your participation. Closing this session, we will have the group photo to commemorate this moment. So Then we will have a 40-minute break and we will resume the panel discussion from 13:20. So we prepared a very fruitful session in the afternoon and we will see you in 40 minutes again. Thank you very much.
우리 하티 그리그리스 사장님도 화면에 띄워주시면 같이 단체 사진 찍으면 네, 2025 제19회 세계해양포럼 조선 세션, 조선산업 패러다임 변화와 마스카르 기회로 세션에 일찌감치 자리해 주신 여러분 정말 감사합니다. 우리 패널 토론에 참여하실 분들께서 자리하시는 대로 우리 세션을 시작하도록 하겠습니다. 잠시만 좀 기다려 주시면 감사하겠습니다. 네, 여러분 다시 뵙게 돼서 반갑습니다.
Great to see you all again. So we are joining the shipping session in the 19th World Ocean Forum. We have experts from the various fields, and we already heard great presentations in this morning. But in this afternoon, we will have the in-depth panel discussion. Then I will hand over the microphone to the moderator, Kwang-hun An. Hello, everyone. Good afternoon. So you joined the presentation session in this morning for quite a long time, but in this afternoon, we also have the panel discussion with a more specific topic. So if you have any questions related to the presentation in the morning and also the discussion in the afternoon, you can leave your questions and comments online and offline. Then we will answer to your question. Then we will start the afternoon session. Thank you for introduction, and nice to see you all again. In this session, we have all the panelists next to me. Right next to me, I have President Yong Sok-seo from the RIMS. And next, we have Mr. Bae Jung-chul from the Komeri. And also, we have Dr. Kim Jin-hyung from the Korea Registration. And he is covering all the green environment technology team. So we have Dr. Kim. And also Mr. Byung-hyuk Yoon from the Samsung Heavy Industry. I believe that he is a true witness of maritime industry of Korea, FPS, and also the LNG FPSO. All the large-scale EPC projects for the maritime industry was handled by Mr. Yoon. He is one of the leading experts in the world. So we have Mr. Yoon from the Samsung Heavy Industry with us. And lastly, but not leastly, we have Kang Hyun Song from KR. He is a director of the Eco-Friendly Ship and the Marine Research Institute of Korea Register. And he is working for the KR for a long time. And he was the Marine officer. So I believe that he can give us the great insight to us too. So the topic of discussion was selected by people in the industry and experts and the people around us. So I gave the topic in advance to the panelists. So I will ask the questions to each panelist, and the panelists can answer to the question for 3 to 5 minutes. After listening to all the answers from the 5 panelists, we will have the cross discussion about that too. Then I'll ask the question to Mr. Seo. Korea is getting attention as we have the MASCA era now. So the order book is full until 2025, and we are receiving the order for the 2030. All those vessels are the high value vessels. And now we try to have a technological lead so that we can make the big gap between the Korea and China. So Korea is having the very special technologies and the high technology. So I'd like to ask a question to Mr. Seo. So what will be the global trends? And what will be the Korean technology, which we can have a big gap with the other countries? So what will be the future of the Korean shipbuilding industry?
Thank you, moderator.
방금 소개받
I am Seo Yong-seok from RIMS. So for small and medium-sized shipbuilding industry, and if we think about the Korea's prestigious power of the shipbuilding industry, I know that the small and medium-sized shipbuilding is not that well known. The market itself, if we include medium-sized shipbuilding, we have some export volume, but small-sized ship is built for domestic purposes. And mainly we make or provide vessel for leisure and special purposes. And the size of the vessel is around 10K tons, and length is less than 100 meter. It is for coastal transportation. So it depends on the domestic market. So if you look at the recent trend of MASCA, we talked a lot about the defense industry in the perspective of shipbuilding, but for us, the impact from MASCA from the U.S. is not that big. And as we are in the initial stage of the market growth, I'm not sure that it will have direct impact to medium and small-sized shipbuilding. And leisure industry globally is quite huge, but for Korea, it is difficult for us to take on that opportunities. We have many challenges for that. So for Korean perspective, small and medium-sized shipbuilding mainly concentrate on domestic commercial, leisure, and special purposes. If you see the order book for medium-sized ship globally, it's around 1.16 million, and the weight for or market share of this industry is quite low, 26%. And in Korea, 90% of the order book is taken up by big vessel, mega vessel, and medium size 7 to 8%, and small vessel takes up only about 5% of the market share. From the country's perspective, for us to advance the industry, we will have to focus our efforts on a large-scale vessel. We have technological prowess in this field, and then our shipbuilding technology is leading the global industry. So based on that competitiveness of Korea, we will have to make an ecosystem where medium and small size shipbuilders can live together. And for this, I believe that there should be some support from the country and the industry. Let's see technological trends. Many speakers in the morning session have covered that. I will not spend much time to explain about this, but medium and small size shipbuilders are following that trend. For example, decarbonization and then reducing the weight of the vessels. They are really important for us too, and we will have to further advance the technology related to those. Nowadays, we are seeing a lot of opportunities from the defense industry. So we will have to focus more on repair and maintenance. In the past, we only focus on new shipbuild, but when the industry expands, then medium and small size shipbuilders will have to take that opportunities to expand their services for repair and maintenance. For that, we will have to consider how we can play our role within this ecosystem. And for Korean medium and small shipbuilders, as the circumstances or landscape of this industry is heavily focused on large vessels, I hope that the country can support us in terms of policy and technology so that medium and small shipbuilders can play our role within this ecosystem. However, medium and small size shipbuilders, in terms of technology, we only have 30% of technical maturity compared to big companies. Therefore, we can say that the environment is not that favorable for us, but on the other side, we can say that we have much potential for growth. When we can further advance our technology and when the industry landscape changes, then I think the structure can change to include more medium and small-sized company. And if that is realized, then Korean medium and small-sized shipbuilders can expand their role. But for that, we need some talent. And policy-wise, there should be some support for medium and small size company. And for the industry, there should be an ecosystem where MSCs can make profit. Yet, it is not that sufficient now. In going forward, I hope that the shipbuilding industry of Korea can think about these issues to find a solution and advance together. And I think that's an important issue. Countries around the world are making efforts to maximize the competitiveness of shipbuilding industry, and then they are introducing a lot of super gap technology. Of course, Korea will have to compete with China by expanding the super gap power that we have. But what's important here is to enhance the manufacturing efficiency and increase manufacturing capability and capacity. The cutting-edge technology that we have right now should be applied to the industry practically. And from the shipbuilding industry, what's important to those technologies, how we can incorporate that and actually manufacture those. So application development should go hand in hand, and of course the research power should go together. So related to MRO business, which is gaining a lot of attention these days. So far we have depended on Europe market and technology, but in going forward, we will have to think how we are going to maximize the profits in the MRO business by using our technology. And this is also important for medium and small shipbuilders, all in all. Now, what's important for us is how we are going to restructure the domestic ecosystem, industry ecosystem. And the government will have to set its own direction and policies to lead the industry. I think a clear plan is needed. Another thing is that, as mentioned before, everything is related to talent. We need to reskill the existing talent, but at the same time make room for new talent and new hire. Together, we will have to consider this on how to attract new talent. All these aspects for the small and medium-sized shipbuilding industry to further advance this industry and to contribute to defense and security. I think these are the points to consider. Thank you.
예, 감사합니다. 소영
Thank you for your comment. Please give him a big round of applause. So Korea is enjoying the boom of the shipping industry, but only with the shipyard we cannot survive. So only when we have the enhancement of the revitalization of the small and medium shipbuilding companies can continue this boom in our shipbuilding industry. So I believe that the change in the regulation and the policy should follow to continue this kind of boom in the shipbuilding industry. So we will receive the question later. And next, as a result of the transformation to the green shipping and the idea for the ocean transformation, and the role of the equipment is very important. 60% of the core parts are imported right now. Also, Mr. Hachi-Grigoris said, due to the trade protectionism and the trade blocked and their own manufacturing, it is very difficult to build all these supply chain. So if we don't have the equipment and the parts industry, we cannot make the integral shipbuilding industry in Korea. So Mr. Bae will talk about the core equipment industry cluster for the green ship, and also he will talk about the roles of industry, academy, and institute to advance the Korean technology further. Thank you for giving me the chance. I am Jung Chul-bae from Komeri. So Mr. Hachi-Grigoris talked about the significance of the equipment and parts, and the transformation to green ship was also mentioned by the previous speakers. So everybody know about it, but looking closely, the transformation of the green ship is the transformation of the equipment, because vessel itself doesn't change. So we talked about the icebreakers in Arctic routes. So for the Arctic routes, we need to have the green ship for the better safety and the better environment. And also the KK Lee talked about the ammonia propulsion fuel without the carbon emission. And also, yes, Professor Lee talked about the SMR, and also the Taejin Lee from the Hyundai industry, heavy industry talked about the transformation (OX). So the decarbonization and the digitalization should be done before we are moving to the green ship. But all that is possible only when we have a strong supply of the equipment and the parts. As moderator said, it's a kind of ashamed because Korea is a number one technology country in shipbuilding, and the volume is much bigger in China, but the shipbuilding technology and shipbuilding equipment and design are Korea's strength. But we need to have more strong supply chain of all the equipment and parts. So we have at the parts level and the equipment level and the unit level, like a skid level components. So all those are the modularized and skidified. Even though we have a advanced technology, but the supply of the equipment are not secured. Like 60% are imported from other countries. So we have to overcome this to become a strong shipbuilding powerhouse. So I want to talk about that first. We have to build a strong national infrastructure, which I mean, like for example, the equipment in the Generation 4 icebreaker is a categorized 1, which can endure minus 45 Celsius degree, and the test acceptance criteria is minus 70 Celsius degree. Then we have to have those kind of test facility. Only then we can develop the technology and test our technology here. But this facility cannot be built by the company, commercial company. So our institute, Komeri, has a part of it, but we need the better and the bigger test facility sponsored by the government. Thankfully, the government gave some support for us to have the ammonia test facility. So we will complete the facility next year. So that the Korea can develop the ammonia powered ship. We need a support from the government to build the test facility. Even after ground verification is done, we need the demonstration vessel infrastructure. Now we are building 17,000 ton vessel, but we need the demonstration facility to test it. So I believe that those kind of test facilities should be expanded so that all the technology developed by Korea can be verified and validated through the test facility. Secondly, we need the company industrial cluster to increase the competitiveness of each company. We estimate the 1,000 equipment and the parts companies in the shipbuilding industry. Based on our statistics of the companies which provide 50% of the parts and equipment to the shipbuilding companies. So we need to have a tighter vertical industrial cluster. For example, in the automobile industry, we have like a first vendor and the second vendor to provide parts to the OEM. But that kind of verticalization is not established yet in shipbuilding industry. So as Mr. Haji Grigor said,
되겠습니까? 그러면
the order of the shipbuilding will decrease. So we need to export our ship, and then that would be possible only when we have the vertical clusterization of the equipment and the parts companies. In order to do so, the companies has to have the open and sincere communications among them. And then it will lead to the international competitiveness. Horizontal cluster is also needed. What I mean by that is, from the materials to the IT technologies, we have a huge variety of technologies. So the vertical cluster is a linkage of all companies from materials to the IT. The shipyard is located in the Ulsan and the Gaje and in the Haeundae. Haeundae has more ICT companies, and Ulsan has more like manufacturing and the machinery companies. But we don't have the vertical clustering. So we see the less number of collaboration between the machinery companies and IT companies. So we need to build such kind of network so that we can make a synergy in the shipbuilding industry. So I will do my best for that. But I also like to ask your support and the participation in this movement. And lastly, we have to compete with the international companies from now on. And then in order to do so, we have to have a super gap where the overseas company cannot catch up with us. So for that, we need the vertical and horizontal integration, and it can be done by national policy. So I hope that we have the paradigm change in the national policy too. As we have the new administration, the shipbuilding industry became a very important industry in our economy, but they don't understand the characteristic of the shipbuilding equipment and the parts companies that much. So this shipbuilding equipment and the part industry, part companies should be considered as the one industrial sector. And I like to suggest that to the new administration too.
Once again, please give him a big hand. So shipping equipment, as other industry, when the infrastructure industry falls down, then the industry that belongs to that or on top of that fall together. I hope that the equipment industry and Komeri is leading a lot of efforts to grow the equipment industry. But as Korea shoots for nurturing super gap technology in the shipbuilding industry, in going forward, we will use ammonia and hydrogen and SMR. I guess equipment industry will have to be prepared for that. Next, I would like to invite Mr. Kim Jin-hyung from KR. You have visited IMO meeting a few weeks ago, and when I had dinner with the ship owners, I've heard that we have talked that IMO failed to reach an agreement at MEPC, and we had a lot of concerns on the future of Korea shipbuilding industry. And many concerned whether our future is gloomy or not. The reason why I'm mentioning this is because in 2013 and before that, and after 2020, IMO announced its decarbonization plan, and many people were suspicious whether that can be realized. And many people mentioned that instead of placing order for different engine, we should place order for ammonia engine. But it was really challenging to persuade them, discussing about the way forward. So Korea shipbuilding industry spent a lot of time considering about the countermeasure for the decarbonization. So that's why we have strength now. But anyway, the decision has been suspended or delayed. But when it comes to climate change, while adapting to the climate change, it may take some time, but initiative or plans related to that will have to enter into effect. I think the future is quite positive and promising, and we'll have to join our hands. I think the comments from Mr. Kim will be really important in this aspect, and I guess many will be curious about what's your take on that. In going forward, the greenhouse gas regulation or decarbonization regulation will be sustained. And IMO regulation might change as time goes by. But what's important for us is to set up our countermeasures to the changing regulations so that we can quickly adapt to the change and boost our industrial competitiveness. So I would like to know the sustainable strategy for Korean shipbuilding industry. Thank you for the question. As you well know, decarbonization of the vessel is required when we make new ships. It's a technical regulation. For example, it's a fuel regulation or standards for a vehicle. Vessel also need to meet certain requirements so that we can deliver the new build to the ship owner. So there is a regulation applied for the new build. When we deliver the vessel, then the vessels goes on voyage, and every year they need to report their CO2 emissions, and there's another regulation applied to that. But the problem is vessel decarbonization regulation is led by IMO. Not only that, there's another regional regulation such as EU, and those are implemented at the same time. That's why it is difficult for shipping companies and many stakeholders to establish their own strategy. As there are many stakeholders related to decarbonization. And another point is that IMO and UK, EU introduced different regulations, and that's good. that can be redundant, but we will have to take it. But detailed guideline or detailed regulations or provisions that apply differ by regulation. Therefore, it is really difficult to set up our strategy. For example, LNG. There's some regulation that control the CO2. And in that regulation, LNG seems to have 30% reduction effect compared to HFO. But when we think about other gas emitted out of LNG, then we'll have to think about other standards, for example, methane slip, and then LNG is negative than HFO, according to that regulation. But as mentioned, the regulations are different and provisions are different by regulations. And there's no standardized decarbonization regulation internationally. So that's why shipping companies and equipment companies feel difficult to set up their optimized strategy. And the same applies for shipping companies. In the past, fleet managed by a shipping company, they set up their own common strategy for that fleet. But now they need to think about different sea routes and need to set up strategy by vessel. So that's why it is so difficult for them. And vessel carbon regulation, some say that it's difficult to adapt to the carbon tax or carbon pricing. It is becoming an economic measures applied. We have discussed many things related to this, but for maritime industry, the decarbonization regulation can be seen like a double-edged sword. Those who adapt to the decarbonization, they can build up better competitiveness, and it's good for them. But for those who are not, then there will be a problem. The carbon price or carbon cost for the existing vessel, when operating the existing vessel, the operation costs, if you see the operation cost, 60 to 70% comes from fuel price. As you've seen from the presentation deck from our previous speaker, compared to the fuel price, the carbon price will go up, and at some point in time, the carbon cost will exceed the portion of fuel cost. If so, then we will have to find a cost-efficient way to offset that carbon cost. And that aspect will become more important in terms of securing international competitiveness, and that will lead to the company's survival. As moderator mentioned before, in October this year, IMO MEPC failed to reach agreement on IMO Net Zero framework. And the U.S. Trump administration announced their own declaration and put some pressure. But IMO, before the beginning of MEPC, had some confidence that NZF will be passed. But that efforts failed and had to be postponed for 1 year. So in the maritime industry, the failure to reach the agreement at the IMO was a big shock. We will have to see whether the agenda is adopted for the next MEPC, but it's not clear. Some say that it will not adopt it as an agenda item for the next MEPC. Then it will be postponed for more, not just 1 year, because the Trump administration will be there until 2028. Then it will be delayed for 4 to 5 years. If we think about shipping companies, equipment companies, we will have to think about whether that's good for them or not. In the short term, they can avoid paying for the cost related to carbon tax, but some may think it's a good thing, but in the long term, I think it will not be good for them. As you know, it takes some time after placing the order of a vessel. Then, after getting the delivery, it's used for 20 years or more. Therefore, uncertainty is something that we should avoid, and the industry really hates uncertainty. But the trend does not change. EU will impose their own regulation. And let's say it's not clear that IMO will discard the NZF or will continue to pursue NZF. So there is huge uncertainty for the mid to long-term plan. Each player will have difficult time deciding on which way to go. I think there will be a lot of unnecessary inefficiency in terms of time and costs. I have covered so far the situation for the shipping companies. I am from KR, and as there is person from Samsung Heavy Industry, but I would like to say that for the shipbuilding industry, before going fully to net zero, LNG will be there for quite some time, and there will be more orders for LNG for the time being. And whether there will be order for a net zero carbon vessel, we will have to keep close eye on the move from the Trump administration, and stakeholders in this industry will make their own plan. So it depends on their decision. Regardless of geopolitical situation, we see some challenges related to net zero fuel vessel. The first one is fuel cost, and second is supply chain and stability and safety for the vessel. So I have mentioned about decarbonization, regulation, and carbon price. For that, it's important to strike price parity or narrowing down the gap between the new fuel and fossil fuel. And for that, we need to stabilize the supply. One of the major carbon prices, even though it is suspended, we have IMO Net Zero Framework and we have Fuel EU Maritime related to carbon price. And UK, starting from 2026, they will do their own emission trading scheme. Of course, the IMO Net Zero Framework has been suspended, so globally, they will be more conservative in investing in the net zero fuel or next generation fuel. And this can be an uncertainty to the maritime industry as a whole, but we have done an analysis on this. On fossil fuel and alternative fuel, and incentive given to those. Under IMO Net Zero Framework, there can be enough subsidies or incentives given to alternative fuels. And Fuel EU Maritime, in ratio perspective, it's more than that's given by IMO. So I'm very cautious and conservative on this, but for the time being, we will have to focus on EU vessels on the EU route to secure the supply chain of the fuel and make investment for the vessels that goes onto the EU route. And as we use more and more expensive fuels, we will have to invest more on technology development of energy efficiency of the vessel. The importance of energy efficiency of the vessel will go up, and I think the market for this will be revitalized. However, in terms of energy efficiency technology, there are some challenges to be solved. In terms of performance, we need to have an assessment method that is objective, and again, we need to standardize how we measure the performance of the energy efficiency in order to eradicate any uncertainty related to this. So, carbon capture and sequestration on board, there are some interest on this, and for that existed for quite some time, and IMO also discusses this. So on-board carbon capture and sequestration. Korea suggested that idea to be the agenda item to be discussed at the IMO, and KR took the lead in recommending the agenda. As we have many order placed for LNG vessels, and many shipbuilding companies understand that LNG is not the ultimate goal, it's just a bridge technology. But what we're trying to do here is to have a certain market share for the time being, and in the long term, we are going to add plus alpha technologies. And that one of that is to have carbon capture and CCUS on board. So that's why we have joined hands with other countries to discuss about the onboard CCUS technology. So even at the time, KR explained that for CCUS, many shipbuilding companies and equipment companies developed the technology, but there should be certain incentive to be applied practically. But decarbonization regulation doesn't recognize CCUS to have certain incentive given. So that's why it was difficult to persuade the countries to go with us. However, Korea's position is that all the decarbonization regulations should consider CCUS as one element to give incentive. But at the IMO, even though we may reach an agreement, that's not all, because carbon capture technology is just an initial stage, because once we capture carbon, we'll have to store it and then make a product out of that and use that. That's the only way we can make a practical usage of CCUS. And let's say we capture carbon on board. There should be infrastructure so that we can discharge those stored carbon on the vessel. But there's no storage site for the carbon utilization technology that should be developed at the same time so that CCUS can take deep roots. This is it for me. Thank you.
예, 감사합니다. 그동안 갑작
Thank you for your comments. You have made a sudden decision from the IMO, but you explained about it very well. Personally, I'm concerned. The shipbuilding will respond, but the shipbuilding and the shipping is always are connected to each other. So even though the IMO's decision was made, but we have like three kinds of the elements we have to. There is a regulation for the local area which can be stronger than IMO. So all those regulations are also received the application. So there are like concerns and the confusions that you must be wondered about this too. So after the first round of the question, let's talk about it again. Next, we have Mr. Yoon from Samsung Heavy Industry, and my question is that as an expert, so the marine industry also try to go to the green ship, but many people suggest renewable energy too. But some are worried about the efficiency of renewable energy. So next to LNG, ammonia, hydrogen, and SMR and renewable energy can be option for the green decarbonization. But renewable energy is like solar, wind, and SMR. So what is the future renewable energy technology do you expect? To be competitive and valid for the future? And what kind of preparation should we make for that? Hello everyone, I'm Yoon Byung-hyuk from the Samsung Heavy Industry. I was in charge of the maritime project since I entered the company for the last 23 years. A big change in trend was the energy. So in that trend, we continued our maritime industry. Maybe that is the same for the other major shipyard. We have to change our energy in maritime from oil to gas, because this is the era of the gas energy. And in the big framework of the gas energy, we are making profit. Then what will be the next energy? I believe the answer to that is the big stream of the energy transformation. Some people said that the ethanol is the answer, and some people the renewable energy, and some people SMR. Nobody knows. But the safest guess will be the hybrid energy. Fundamentally, but under this energy transformation, there is the issue of money. Dr. Kim talked about this, but the energy unit cost is a key factor to make this energy transformation. You have to see how much you pay for your energy. So what price will be affordable for you? Like 131 per kilowatt of the electricity, that is the appropriate level for the people to accept. But can we generate the cheaper energy than that? So we talked about the nuclear energy. So we make the 71 per kilowatt nuclear energy, the electricity from the nuclear, and with the gas and with the coal, what's the generation cost of electricity? It's around 80 to 121. Then what about the renewable energy? It's around 130 to 260 per kilowatt. Then is that a commercially viable option? The company cannot survive with that price. So that is why the company needs subsidies from the government. The reason why government provides subsidies to company is to win the votes. So MEPC 83 was not ratified, so the many people are regretful about it. But many of you do not expect that this will fall down forever. The ratification will be done eventually because that is our survival strategy for the whole planet. When we didn't have the internet or the YouTube, the information was limited, so people cannot agree to a certain idea. But now everybody now on the planet think that we have to go eco-friendly to save our planet. Everybody has reached that consensus, and they will make the number of votes, and that they will move the government and policies, and that it will generate the subsidies of the policy, and there will be the power to run the company. So, in some sense, we have to make the virtual cycle of this kind of the movement. Now the Samsung Heavy Industry is making profit from the LNG project because this is the era of gas. We prepared that for last 15 years, and now we are making the profit. Then what should we do for coming 15 years? So I think that is what we are doing right now. Renewable energy is expensive for now. Then how can we make this renewable cheaper than gas, which is 130? We have to think about this continuously. That's the activities of a company for survival. So most of people say it is impossible, but the companies always try to make innovation just for the 1% chance, because they will make a profit and then they will multiply the value of the companies. That's what we are doing right now, and that is the way for the private sector and academia and the institutes to seek for in the future, and the government should support it, and government should lay the foundation for that. So the private sector, academia, and institute, and the governments need a collaboration. And I believe that can make the cycle, virtual cycle for the industry, and there will be the fuel for the transformation. I think that is the fundamental of all of our discussion. We are preparing the offshore wind energy. That is our major businesses now. So maybe in 10 years, we can make that electricity with the 81 per kilowatt in 10 years. And we try to come up with many solutions to provide answer to this kind of goal. So that's why we call all our activities is the way for innovation. And 10 years ago, our company also worked on the wind turbine. But now we moved beyond that because we have a lot of wind turbine manufacturers in our country and in other countries too. So the price will go down through the competition, and then we try to find what we can do beyond that. So that is why we are looking at the offshore wind energy. And based on what we did for the last 10 years, the shipbuilding companies are very good at the steel plate welding. So we have a know-how, we have a data. So we are thinking how we can utilize those kind of information for the future energy industry. We try to make what we are good at our future businesses. I believe that from what we are good at, we can make innovation. And we can make a plan and we put them in practice. So the companies are trying to make an innovation, and the government should provide the support for that. I hope that circle can be made in our industry. Also, we have difficulties of the increasing labor cost. U.S. and North America, Australia, and the Western Europe are also facing the same problem. So after COVID pandemic, that became very obvious across the world. So that stimulated automation. So we always think how we can produce our product cheaper. So that's what the companies do. So automatically company turn their eyes on to the automation, and it will bring the innovation much faster. So we talked about digitalization, automation, and autonomous navigation and AI. All those words shows what companies are doing to save the labor cost. So we have to realize where we stand now, and we have to simplify it through the automation, and that is all the stages the shipbuilding companies and the other industrial companies go through. Usually the shipbuilding industry has a 10-year cycle. So one of the panelists talked about the vertical integration and the horizontal integration. But I believe that the shipping industry is most conservative about it. So IT industry is very agile, and even the aerospace industry is agile, more agile than the shipbuilding and maritime industry. So we have to try to shorten those kind of long cycle. Maybe that is the attribute of our industry, but we try to do the automation and the transformation under those kind of circumstances. Maybe that is all from my side. Thank you.
그 좋은 말씀 해주신 윤명혁 상.
Once again, please give Mr. Yoon a big round of applause. Lastly, I would like to invite Mr. Song Kang-hyun from KR. Everybody says that we are enjoying a boom in the maritime industry, but I have been in the management position for a long year, but instead I see that we are living in an era of super or hyper uncertainty. Because due to power struggle globally, there is some direct impact to society and economy. And all those decarbonization regulation is also uncertain. There will be some agreement reached anyway, but now there is so much uncertainty. And as our speaker in the morning mentioned before, many people turned to protectionism that will impact the logistic volume or cargo volume of the shipping industry. So there will be less vessels at sea. Then how we can address these challenges can be a key to the future. And another hot topic is digitalization in the shipbuilding industry. In the process of pursuing digitalization, then how shipbuilding and shipping industry should pursue coexistence and growth. For example, finance, shipbuilding and shipping company, and many other stakeholders will have to make a consultative body to make a better ecosystem. Is there any other way that we can pursue a better future? Thank you for the good question. As you know, KR is closely related to our shipbuilding and shipping industry, as well as equipment, cargo owner, insurance, R&D, government. These are the stakeholders of KR, and we are doing collaboration with all of the stakeholders. So you asked about the future direction of the shipbuilding and shipping industry, and let me share my view. There are so many opportunities for Korean shipbuilding industry due to IMO GHG regulation. 95% of our current vessels use HFO, and this many vessels will have to use alternative fuel or newly built. So I think this is a great opportunity for us, but at the same time, there's a competition from China. We need to go beyond and surpass the market share that China has, but currently there are a lot of worries. CSSC and CSIC got approval from their stock market. They are listed and they merge, and they take up around 2/3 of the global order, and one shipyard is producing that much vessel. And then many shipyards under their umbrella, and they allocated to a certain vessel type to maximize their operating profit, and then the operating profit will be reinvested to their R&D and business structure. So that's worrisome. To compare that to Korean shipbuilder, tanker and bulk carrier, they are 20 to 30% cheap in China. And as Mr. Ton mentioned before, we are concentrating on high value added vessel, ammonia, CO2, and LNGC. But later on, China will take up that market again because they're vamping up their capability to follow fast in that field. And as Mr. Yoon mentioned before, what's important is people cost. When you visit China, I was really surprised to see that they work overnight. They work in 3 shifts. The strength of Korea shipbuilding industry is speed, but China is really speedy nowadays. To compete with price with China, I think we'll have to further make efforts, but it is really difficult. As other panelists mentioned, one way to survive is to have a super gap technology so that they cannot copy. And we have to be the licensor so that others cannot copy and paste. And all the needed technologies have been covered by panelists, so I'll skip that part. So let me instead turn to future direction. If you see the circumstances of China, just like Korean shipbuilding industry and others, China have a one ecosystem for shipbuilders, equipment companies, and banks and insurance companies. So far, they failed to do so, but they are cooperating. For us too, I think cooperation is not an option. It's a survival tactic. Of course, for technology, we need to compete with each other. But for those, we can collaborate. For example, R&D or testing lab, or ways to nurture equipment company. I think 3 major shipbuilders will have to invest and join hands. And another collaboration needed is between big companies and small and medium-sized shipbuilder. Due to entry tax or entry tariff for the vessel to go to U.S. ports, there are a lot of problems entangled with that. So let's say major company can do the design and small and medium-sized shipbuilders can manufacture, and that's a good model for collaboration for Korean companies. And again, SMEs and equipment company need to collaborate. I know that certain shipbuilders are closely related to a certain equipment company, and they don't like that equipment company to supply their products to other shipbuilders. But we need to break that shackle. So one good idea is to nurture equipment companies together by 3 major shipbuilders. And I think shipping companies and shipbuilders need to collaborate. In the past, placing order to the shipbuilder was the end of the relationship between shipping and shipbuilder. But nowadays, we see a lot of technology and digital equipment. And for the crew members to get familiarized with those technology, it's not enough to give the product to them, but the shipbuilders need to give support to the full life cycle of the digital vessel. So shipping company and shipbuilders need to join hands to do testing and training as well as operational tests. And shipping companies have different views. For major companies and small and medium-sized, they have different opinions. For example, tankers, they cannot go to LNG or other alternative fuel because CAPEX is too big. And cargo tank size may be reduced, so the only choice they can make is HFO. Instead, container vessel and PCTC. Those 2 types of vessels are highly getting pressured by cargo owners and GHG regulations. So we need to integrate all the shipping companies to come up with ways to do GHG reduction. I think that's a pooling system that we should aim for. So giving penalty for the ones that doesn't follow. And once we introduce the pooling system, I guess major companies and SME can survive together. And Mr. Kang-gi Lee, KK Lee, mentioned about green shipping corridor. I think ports, government, and shipping companies need to collaborate in that aspect. So, for example, when the green fuels are not supplied by the ports, then we cannot operate the GCS. For example, Maersk and other major shipping company mentioned that if there's no seamless operation, CMOPs, and when the fuels are not supplied, then they will have to pay a lot of penalties at the port due to GHG tax. So they announced that they will not make call to that port. We need to secure green fuel pipeline at Ulsan or Pohang. And KR, or class societies, there's no certain GHG regulation introduced, and one provision of the IMO may decide the future or destiny of the industry. So it's really important, but there are so many technology being created nowadays, and class society need to prepare for safety regulations and then do onshore testing, COMETI, RIMS, CRISO, and we have many good testing facilities at the shipyard. I believe forming a network of all those so that we can share the testing capability is important, and all in all, shipbuilding and shipping companies should be prepared to do on-sea trial, and demonstration facilities needed, and that's underway. And all stakeholders need to cooperate in building the testing center. Thank you.
마지막에 정말 우리
So he suggested the idea, like future way for Korea to go. We need a coexistence and a collaboration for the survivor in the future. So I really thank your comments, Mr. Song, and please give him a big round of applause. Okay, so we talked with these 5 panelists. My question to each panelist was advised by more than 100 people in the industry. So we don't have that much time because we have the other great session later. So if you have any question, maybe we can entertain 2 questions. Also, for others who have more questions, you can leave your comments online that we can answer to the question. Okay, Mr. Kwan? Hello, I'm Oi Kwon, the president of MT Korea. Thank you for your panel discussion. Each of you gave us a great insight. So Mr. Song said we need a collaboration. I also think the reason why we have this advanced shipbuilding is from the collaboration. So we had a great design and a great manufacturing, so we could become number 1 before the Japan and China. So, but we had the bad experience about the design technologies, which was done by the other countries. So I have a question to Mr. Bae. When we talk about the zero carbon, we will go from the oil to gas and the ammonia. But a small and medium shipping company has the design. But if we go for the SMR, the ship building company do not have any a design capability, and that can be the black box. How can we have a collaboration between the shipbuilding and the energy company? So can I answer to that? Thank you for your great question. So as you said, in order to go for green shift, we are moving toward the gas fuel, and now we are using the LNG gas. Most of ships are equipped with the DF engine, but currently mostly they are using the HFO because of the problem in the LNG supply chain. They are ready, but they are not using that engine yet. To prepare for the net zero, SMR can be an option, as we heard from the presentation in the morning. So there is the Korean-owned technology. We have the prototype, and that is under test now. So when we go for the SMR, what kind of thing to do as the equipment, the parts company? So we also asked that question to ourselves. All the equipments in the large light water reactor, there are 17 test items. 11 can be done in Korea. 6 tests should be done in other countries, or other countries should come to observe the test. So even large nuclear power plant installation can be done, but among the 17 test items, still we are depending on the other countries for 6 test items. So that means even we go for the SMR, maybe we need the support of the overseas countries for the test, and also we need to have more safety features like the containment vessels and the all other technologies. So the nuclear supply chain should work for the shipbuilding by encouraging them to pay attention to the marine industry. So in summary, we should make our effort, but the nuclear energy suppliers and vendors should have more attention to the maritime industry. We have to encourage them, and the monitoring and then test facility for like containment vessels and the walls should be equipped in the maritime industry. So that's why our Komeri, our institute, try to receive more financial support from the government to build the test facility in Korea. But frankly speaking, still we have a long way to go. It is the high-hanging fruit yet. Thank you for your comment.
부장님,
So to the question by Mr. Kwon Ho-ik, Mr. Seo Yong-seok, I think you should say some things, because for the future technology, big shipbuilders and medium and small size shipbuilders can cooperate. So do you have any plans for that? In the shipbuilding industry, the technological advancement is led by big companies. For labor structure and infrastructure aspects, compared to SMEs, big shipbuilders are far above. But I have touched upon this point before, but what we are discussing a lot right now is SMR. Big shipbuilders are analyzing and researching whether SMR can be applied. But if you see the cases of SMR vessels, they are medium-sized and small-sized mainly. So this means that when there is a technology newly developed, from the perspective of testing and applying for the first time, in case of the vessels, there are some share for the medium and small side vessel to play its role. I think there are a lot of advantages held by small and medium-sized vessels to test those new technology. But it is difficult for the SMEs to lead the technological research and development, but the technological maturity isn't there. Therefore, first thing to solve is to see whether the technology developed by the big shipbuilders can be tested and viable, and the process of testing and applying in real life, we will have to discuss or make an organization to discuss the entire chain or entire life cycle of that technology until the testing, so that medium and small size can participate. And I think there is a role to be played by the government, and I think government will have to intervene more actively. Thank you for your comments. So, to prepare for the future, it is difficult for an individual or individual company to survive on their own.
Whether it is technology or not, coexistence is the only way for survival, I think. So we will receive the second question from floor.
University professor. Mostly everyone speaker of the panel session mentioned talents or lack of human resources. Could you give the definition of the talent? Is it a young person just graduate from university, or is young PhD, just defended his or her PhD thesis? Who is talent? How you define it? Thank you.
Social issues exactly is the resources is, I would say, for the shipbuilding and offshore industries in Korea is, we have been, as I said earlier, is the cyclic of the changes is a very conservative industries, as I said earlier. It takes about 10 years to change something and to do something differently. It requires at least 10 years. And the way we're doing it at the moment is we're using people. We're using people's hands. We're using people's thinkings and we're drawing ship engineering documentations with people, with the keyboard and mouses. That's all people, not robots or automated. So that's what it is today. And can that be changes in instantly, in few months or even 1 year? No, it does not. So that's what this current situation is. If you have different industries, they may have faced different situations. But as far as the shipbuilding and offshore industry is concerned, clearly that's a very, very slow, very, very conservative and very slow changing industries. The nature of it requires the people's hand to produce outputs, which is ships and offshore plants, offshore platforms. That's what it is today. That's, at least from a shipyard perspective, that's how we see it. Hope that answered your question. Thank you.
예, 그 질문에 대해
For the question, is there any other panelists who can add on to that?
Very interesting
한글
questions.
뭐 한글로 해도 됩니다. 한국말로 해도 됩니다.
May I speak in? Okay, thank you. 굉장히 이제 좋은 질문인데 또 학교에서
Thank you for the good question. As you are from the academia, I'll share my views more freely. What kind of degree that we want in terms of PhD or bachelor. Before that, then we need to see the essence of the problem that we face. The shipbuilding industry is a very conservative industry and it has been there for hundreds of years, and it's kind of a boring industry, but it is facing a lot of challenges. For example, GHG, digitalization. In case of KR, in the past, 90% of our researchers were from architecture or engineering, but the background is now has been diversified. So the thing that I would like to mention to you is that the challenges that we face need creative minds. Those talent will have to take action, not just take on the past knowledge. They need to have that energy to put thinking into action. So those are the talent that we need in this industry. I hope that this can answer your question.
Yes, I am moderator, but I want to also talk about that too, because we have a lot of students online streaming, so I'd like to say something. So I've been working for more than 40 years, and I'm the CEO for like 10 years. And I always see like two aspects when I hire the staff. And also I give these comments to the students in my school too. First thing is that all the talents company wants and that the talents institute wants are the people who has a capability in the specialized area, like the master degrees and a doctor degree with the doctor degree, because they are almost specialists. So those capability is highly regarded, and nowadays design and the productions are advanced by the computer work, but the company wants a talent who can be trained well in their company. So if like the people who can learn quickly, there will be no big problem. But I see the two trends in the industry. One is a digital transformation, AI transformation, and it is changing into the physical AI. So I believe that students should learn about this kind of features in school, because it takes long time for them to be trained in the company. So all the requirement courses in school should be changed in school. They have to grow out of the conventional academic curriculum. The school should provide the proper and the useful curriculum for students to learn quickly when they go into the company. Now the automation rate is almost like 60% of the whole process. And the number of seafarers decreased because we have an automated system. So green shipping is another word, in another word, automation. Then the number of seafarers will go down. So if they don't have such kind of capability in the new technology, they cannot get on board. And I believe that the curriculum at school should change, fitting to change in this trend. many people say that if then what can man do in the changes of the automation, but the people who control these situations are all the skilled workers. So we need the other classes of the skilled workers. So I believe that that is the human resources. I think that's what I ask to our students, and that's what I see when I hire people in my company.
Do you have any other question? One more. We will take one more question from the floor. I am from a small shipbuilding company. So related to the shipbuilding industry, while listening to the presentation, I could see that all the presentations were impressive. But the condition is that the industry will develop based on the current framework. Against that backdrop, as IMO couldn't adopt a GHG framework, it has been delayed for 1 year, and nobody knows how that will unfold. But the basics here, those who support the Trump administration, I could see that they have their own reasons. So nobody knows how the future will be. But I guess everybody from this session has some skewed view. For Korea to make more profits in this industry, I'm not saying that all your perspectives are wrong, but I think what I'm suggesting here is that we need to logically understand that the reasons behind those who oppose to GHG framework. So my suggestion is to invite one speaker who opposed to IMO GHG framework so that we can have a balanced view. I have participated in the IMO meeting several times before, but they have their own power struggle and they pass the issues just like so. The reason why U.S. didn't participate there is because I guess there's some money issues entangled there. For example, penalty system, it's not logical, it's too strong. There are some groups that oppose to that idea, and I think they have their own reasons. Earth climate change, I know that has negative impact, but the root cause of the climate change may not be GHG, may not be CO2. We cannot be 100% sure that the root cause is CO2. But now we are seeing CO2 as the major culprit to climate change. So I think there should be someone who could oppose to that idea. CO2 only takes up 0.03% of the entire atmosphere, and the effect of other gas or steam can be greater. I think we are framed by the political attempt being made by pro-environmentalists. So that's what I wanted to say. So next time when you have WOF, I hope that you can invite some speakers who have opposing ideas. Thank you. Thank you for your suggestion. Let's take another question. We will receive one more. So while you are thinking about the question, so let me give you a brief answer to what you have suggested. The concerns that Korea has is that, as Mr. Yoon and Kim mentioned before, there's a shipbuilding industry cycle that changes every 10 years, and we see that the GHG framework cycle will last for a long time. When there's a downtime in the shipbuilding industry, Korea struggles for a long time. So that's why we worry about the GHG regulations. But for shipbuilders and research institutes, environment regulations is one axis of their research. But we believe that the global industry trend will persist and go towards going green. If we only think about economical profits of shipbuilding industry and shipping industry, LNG is our first option because in terms of carbon tax or the price itself. But the reason why we are researching and further advancing at SMR and ammonia technology is because in going forward, there will be price parity reached. But what we worry is that due to protectionism across the world, as Mr. Hatzi Gregory's mentioned before, while researching the global trend, I feel that if against that backdrop, it is really difficult to secure national competitiveness. There are around 300 vessels being made in Korea, and more than 240 vessels are big vessels. And we pay huge loyalty to foreign countries. If we can have that loyalty invested back to our country, then it would be good for our entire industry. But the current situation is not. I have visited a meeting with shipbuilding equipment suppliers and parts company owners, and they had a lot of complaints saying that only some percentage or small portion of that order is being placed to Korean equipment and parts companies. To enhance competitiveness, we only concentrate on mega project and modularized projects. If so, then a small and medium-sized suppliers feel difficult to do demonstration. For example, HC Hyundai invested 300 billion Korean won to establish a demonstration center so that suppliers can do their tests at the facility. That's a good example. But I have talked to Mr. Pyun many times before, but we need to enhance that capacity. It shouldn't be led by company alone. Academia, governments, and government agencies will have to join hands to further enhance national competitiveness. Although IMO regulation is impacting our view, but we are not totally skewed toward their direction. We are checking our order book because we see a changing trend in our order book. Sometimes it's stagnated and there's a different trends that are observed through the order book. So that's why we have suggested this theme to be discussed. So as you have suggested, and when we have another chance, we will reflect your opinion as well. Thank you.
추가 질문이
Any other questions? So we had a long panel discussion. So I believe that you don't want to have more questions. If you have any, please send us. Then we will answer to your question. Then with that, maybe we will close the panel discussion. And let's give them a big round of applause again. Thank you very much. Thank you all for your in-depth discussion. And also, I thank Mr. Kwang An, who was the moderator for the panel discussion. And I also thank all the participants for long presence. So we can close the panel discussion now, and then we will start the epilogue session again from 4 o'clock in this Crystal A room. I'd like to ask your participation in the 4 o'clock session.
네, 잠시 안내 말씀드리겠습니다. 잠시 후 저희 마지막 세션이죠. 에필로그 초불확실성 시대의 파고를 넘어 그 이후 세션 진행하도록 하겠습니다. 참석자분들께서는 입장하셔서 착석 부탁드리겠습니다. Well, ladies and gentlemen, we will get started really soon with our last session titled Epilogue. So I would like to ask everyone to come inside and take a seat so that we can get started. 네, 그리고 통역 안내 드리도록 하겠습니다. 저희 동시 통역이 제공이 되는데요. 앞에 놓인 수신기 활용해 주시면 되고요. 그리고 한국어는 채널 1번, 그리고 영어는 2번입니다. 네, 채널 맞춰주시면 감사하겠습니다. And we provide simultaneous interpretation. So if you need any receivers, please let us know. 네, 지금 혹시 수신기 없으신 분들 계시면 안내 주시면 저희가 제공드리도록 하겠습니다. Well, we provide simultaneous interpretation. Make sure to use the receiver on your table and turn to channel 1 for Korean and 2 for English. 네, 참석자분들 입장하셔서 착석 부탁드리겠습니다. 네, 저희 곧 이어서 마지막 세션이죠. 에필로그 세션 진행하도록 하겠습니다. 감사합니다. 네, 잠시 안내 말씀드리겠습니다. 네, 지금 장 외에 계신 분들 계신데요. 참석자분들께서는 조속히 입장하셔서 착석 부탁드리겠습니다. But ladies and gentlemen, we still have one session left, so I would like to ask everyone to come inside and take a seat so that we can get started. 네, 지금 장 외에 계신 분들께서는 입장하셔서 착석 부탁드리겠습니다. 네, 저희 마지막 세션만을 남겨두고 있는데요. 네, 입장하셔서 착석하시는 대로 저희 진행하도록 하겠습니다. 감사합니다. 네, 안녕하십니까?
Good afternoon. So now we are having the epilogue session, which is the last session of the 19th World Ocean Forum. Epilogue session, Beyond the Wave of Uncertainty, is a topic of the session. So we will summarize all the sessions we had for the last 3 years in this event. Let me introduce the moderator, In-hyun Kim, who is a the chairman of the planning committee of the World Ocean Forum, and he is also emeritus professor of the Korea University Law School. Please welcome him with a big round of applause. I will hand over the microphone to you. The floor is yours. Hello, everyone. Finally, we came to the almost end of the 19th World Ocean Forum. You are joining now the epilogue session of the forum. The topic of this year's forum is Beyond a Wave of Uncertainty. I am the law of commercial law, and the philosophy of the commercial law is a predictability. Human beings for a long time worked hard for the productivity, predictability. Based on the predictability, we can do the global trade, because when we ship the cargoes, the ship will be safely arriving at the port, so that predictably make the global trade possible. So uncertainty is the one the human being have been avoiding for so many years. Now we are trying to close all the 3-day journey of the World Ocean Forum in this epilogue session. So let me invite Chang Ha-yong, the director of the Future Strategy and Planning Department of the Busan Development Institute, for the summary. Please welcome him with a big round of applause.
Yeah.
Nice to meet you all. As being introduced, I am the one who always summarizes World Ocean Forum, and it is so nice to meet you all. I would like to thank all the participants. There are some citizens and online participants joining us. So for this session, I would like to wrap up what we have discussed, and thank you for giving me the opportunity. So I thought a lot about how we can summarize what we have discussed under the theme of Beyond the Wave of Uncertainty. So it's difficult to go beyond the wave, right? So I do my best to do so. Through this epilogue session, as I have introduced myself, this is a time to summarize what we had discussed for the 3 days. Experts and scholars around the world have joined us to share their insights on what we needed to think about living the time. So it was difficult to summarize as an individual and as a layman. But thank you for the organizing committee. I could have this opportunity to summarize for several years, but this year it felt really different because now I can use generative AI. If individuals has data, then we can do instant analysis and extract some insightful knowledge based on that data. And I could feel the power of generative AI. I have used the tool, and yesterday I have used the AI to make the data based on the presentations given by our speakers. Under the theme of Beyond a Wave of Uncertainty, the 2025 World Ocean Forum has discussed many things, and we have discussed what the humanity has to do to adapt to the uncertainty. And together with the AI, I have come up with this conclusion. And I asked the definition about the uncertainty to the AI tool that I use. And to summarize what speakers mentioned, AI gave the definition to the theme that we had is that we need to go beyond a simple uncertainty defined by crisis, chaos, and disorders as core keywords, where complex factors, for example, geopolitical crises, supply chain risk, hegemonic competition, make predicting even the immediate future impossible. So this was the definition given by AI related to uncertainty. As one speaker mentioned before, as we are living in a hyper uncertain era, and there will be another uncertainty coming up in the future. So it's so sure that uncertainty will sustain. And this is the thought that we share all together. However, the World Ocean Forum has successfully navigated that wave of uncertainty. And this year, again, we have discussed on how. World Ocean Forum has always discussed how to gain resilience through transformation and cooperation. And as a platform for discussion, we try to overcome the waves of uncertainty and usher in a new era of prosperity through international cooperation centered on the oceans and innovative governance. And the conclusion is the formula that's shown on the slide. To overcome the crisis, the maritime industry needs cooperation and transformation. Through that, we will be able to gain resilience. And I think this is the key to going beyond the uncertain world. To overcome that uncertainty, we need resilience. And to gain the resilience, we need to be strategic. And one of the strategic ways to do collaboration. And in order to be future-oriented, we need to have a transformative thought. For the past 19 years, I believe World Ocean Forum followed that formula. To gain resilience, focus on the ocean, we need to cooperate and pursue transformation of the maritime industry. And that's the conclusion that I reached. There were a lot of messages shared by our VIPs, and they shared their wisdom. President Lee Jae-myung mentioned that the Republic of Korea will fulfill its responsibility and role as a responsible member of the international community. And Minister of Oceans and Fishery Jeon Jae-soo has announced his vision for the Arctic Sea Route, and he predicted that the Arctic Sea Route will become more and more important. And Mayor Park Hyung-jun of Busan Metropolitan City has mentioned that humanity has always found new paths at sea, and uncertainty is not a crisis but a sea of challenges. And Mr. Yeom Jae-ho, the keynote speaker, has covered the topic of the Arctic Sea Route, mentioning that if we can incorporate the views on Arctic Sea Route, we will be able to gain geopolitical balance. I think the prosperity of Asia Pacific will depend on blue finance, and I would like to thank Mr. Martin Kering for sharing that insight. And he mentioned that blue finance will become the ambassador of international development framework. So I typed in all the topics that we have covered through World Ocean Forum, and I used the AI tool to categorize what we have discussed, and this is the result of AI analysis. There's resilience discussed by marine, bio, and fisheries, and there's another segment that says strategies needed for maritime transport and shipping. And under this uncertain world, the AI mentioned that the Republic of Korea will have to be more eco-friendly in developing the industry sector. And that was the conclusion or the topics covered by speakers of 2025 WOF.
In more detail, on the third day, I don't have enough time to summarize the older sessions. But if we have a more advanced technology, maybe we can summarize the third day in a quicker way. So this is all the scripts of the speakers on the first day and second day, and based on that, we retrieved the keywords. And it was visualized with the word cloud. So it was a discourse about all the maritime and the forum, just like a conclusion. Cooperation and international and the industry were the biggest three keywords, and the future direction of the maritime. Those were retrieved from the scripts of the speakers. I believe that this is in line with our topic, Beyond the Wave of Uncertainty. So I went into one more step, and then I did the SWOT analysis. Internally and externally, I categorized into the 4 SOWT. So as a strength, we have the global maritime network and the collaborative mechanism, and also the maritime industry is converged, and it is becoming the strategic maritime logistic hub, and it also have an infra competitiveness. I mean, the Korean maritime and the environment. Of course, we have weaknesses or complex structural structure, and also the decrease in the maritime health, and also the gap between the blue economy investment, and also we have a weak regional cooperative governance. But there is also opportunity because we have the multilateral international framework, and the blue finance market is increasing, and we also have the technology-based the maritime industry. But we also have a threat like geopolitical conflicts and the natural disasters, and the political and the policy uncertainty, and unstable regulation, and the biodiversity loss. So through this kind of a SWOT analysis, what strategies this World Ocean Forum provided. So we need to utilize that strength and opportunity, and we have to build the smart maritime infrastructure for the NSR, and also the Korea need to lead the collaborative platform for the blue economy. And also, as the WO strategy, we will issue the blue bond to decrease the gap, and we can enhance the international joint researches to enhance our capability. And also using the strength and the threats, we can build the risk management plan system for the digitalized supply chain, and that is the direction Busan is taking. And also we have to recover these weaknesses, and we have to minimize the threat through the WT strategies, and we have to overcome the complex crisis through the smart fisheries, and also we have to have the multilateral collaborative mechanism to respond to this crisis. So just like I told you, we have so many keywords and key messages from the all speakers. Maybe in other like mass media or the other conference or other like books, and you may access to all those key messages again. And the World Ocean Forum is not just a one-time event. We will suggest the messages for the maritime industry, and we will suggest the direction for Korea and Busan to go forward. During the World Ocean Forum, Korea and Busan received the 5 recommendations for the maritime policy. First is the pioneering the Arctic Sea route and establishing a maritime hub. So the comprehensive strategy and the transshipment hub development, and we make this Busan, Ulsan, Gyeongnam Maritime as the global shipping hub. And also, smart maritime industry and the shipbuilding innovation is recommended. AI-based smart ports should be established, and autonomous and eco-friendly vessels should be sped up. And we also need to secure carbon-free and smart shipbuilding technologies. And the blue economy and the maritime finance, blue finance hub is also important. This blue economy and blue finance should be established in Busan through the multilateral cooperative platform and the international organization, and also the attracting more startups and ecosystem. And also the fisheries innovation and the maritime workforce development was also recommended. We need to have a smart fisheries, and we also have to develop the hub training center in Busan and Korea, and also to strengthen the marine environment and also the international cooperation. The Korea has to take initiative, and the Busan should take initiative to utilize the blue carbon and the implementation of the UN SDG 14. All these recommendations will be organized and summarized to be submitted to the Busan metropolitan government later. Okay, so we had the active discussion, and thanks to all the efforts of the citizens and publics, this World Ocean Forum was held for last 19 years. So in the summary, in one sentence, what about after, beyond the wave of uncertainty? So all the themes from the 2007 until 2025, we always had a crisis and always had an uncertainty. So in this era of uncertainty, the WOF has been held for 19 years to overcome this kind of wave. And we just consistently took a step to go forward. So I'd like to tell you that we made a great effort so far. Thank you very much for listening to my presentation.
Once again, please give another big applause to Mr. Jang Ha-yong for his excellent summary. Now, let me invite the moderator back on stage. Once again, please give him a big hand.
정하용 박사님.
Dr. Jang, I always like this session, this epilogue summary session. You always do that work so well. Thank you for providing that SWOT analysis this year. Let me move on to panel discussion. We have Mr. Kim Dong-sung, CEO Kim Kyu-bong, Mr. Kim Min-soo, Dr. Lee Dae-sung, Dr. Ma Chang-mo, Dr. Yoon Hee-sung, and An Kwang-hun, and President Ho Yoon-soo. Please come up to the stage. Let me invite all the panelists on stage, and please give them a big hand. Please come forward and take your seat. For the past 3 days, we have discussed a lot, and let's focus on what they will discuss from now. And once everybody take their seat, I'll pass the microphone over to our moderator. Once again, please give them a big hand. We had in total 10 sessions, or 13 altogether. So today we have moderators for the 10 sessions on stage. When the moderator couldn't join, then we had the planning committee member to do a briefing of their own session. They are going to provide a brief summary of what they have discussed in their own session. After this forum, we are going to make a book, but the readability of that thick book is so low. It will be about 200 pages. We plan to publish a book, and our moderators will provide their summary for the book. And I would like to thank their efforts. I guess what they are going to share through the session will be in the book as well. First, I would like to invite Mr. Kim Dong-sung to do a briefing on the kiosk session. Before the keynote session, we had that kiosk special session. So for those of you who couldn't join at that session, please provide the briefing. I can give you about 3 minutes. I guess the time is not enough to cover all, so I'll be really brief and quick. In the kiosk special session, as a kiosk plays an important role in global maritime research, we had the discussion. We had 4 presentations. I can give you 7 minutes, not 3. 7? Again, so I'll try to slow down. We had 4 presentations and 3 panelists. And altogether, 7 speakers joined our panel discussion session. The title was Global Research Hub Kiosks. And that was the future vision of the kiosk. And for that, we shared how. First, we have in kiosk research center, 6 of the research centers overseas. We have in UK, China, Qingdao, and in Indonesia and Peru. And in Micronesian country, we have in total 6 overseas research hubs. In the first presentation, we had an introduction to the 6 research hubs. They take on different roles. By the end of this year, we are going to move the UK R&D Center to Paris, to Sorbonne, with Paris, because it was difficult to do the research in a geographically distant center. So that's why we decided to move that to Paris. And next year, we are going to open Korea ACS Research Center in Colombia. By next year, we will have 7 foreign research hubs under kiosk. So far, in the international joint research, we were a mere participator, but our aim is to become a leader in joint research globally. So that was the first presentation. And in the second and third presentation, as mentioned, we have many ODA as a joint international research. So we gave a case studies of those ODA. We believe that joint research is really important in maritime, and that's another big business department of kiosks. In Sri Lanka, we do data platform establishment and e-library installation. For the past 3 years till 2026, some private company also participated, and Sri Lanka contributed their data related to fisheries and maritime, and together with Sri Lanka, we are building fisheries and ocean data center. One of the successful case for kiosks, and MOF takes Korea-Indonesia joint research project as a successful case. We have a Korea-Indonesia Maritime Research Center. So far, we had talent development program and a lot of maritime joint research, and we have invested around 20 billion Korean won to do the ODA for Indonesia. that was conducted to provide support for Indonesian government and Indonesian local community in terms of maritime and fisheries. There are some policies introduced by the government, and the government was really appreciative of our support in terms of maritime policy assistance. Thanks to the Korea-Indonesia project, we could utilize the local industry base and it could take Indonesia as a hub of Asian expansion in kiosk project. And we have LPEM program. This is London Protocol Engineering Master Program. It's a degree course provided by kiosk. And the budget was allocated by Ministry of Oceans and Fishery. We invite government officials from the developing countries so that they can enhance their knowledge and experience in terms of marine environment protection. So far, for the master's degree course, we grant degree after completion of the course. For example, Myanmar, Philippines, and some Asian countries participated. So far, 22 people earned master's degree from 11 countries, and after graduating our course, they went back to their countries. And currently, there are students from 16 countries taking the course. As they are developing countries' government officials, if they speak in Busan dialect, you may think of them as a graduate student of kiosk program because they are learning Busan dialect while learning the course. So while running the LPEM program, we could nurture government officials of developing country, and we have kiosk school. And in the International Maritime Organization, they have ODA project, which is Smart Ship project. And this is a scaled-up version of LPEM. Again, as mentioned, LPEM is a master's degree course, and our goal is to have doctor's degree course as well. And also, we have invited 3 panelists for the panel discussion. And one panelist was from Sri Lanka. And he mentioned that he was really thankful for us to establish the data platform. Compared to the Americas or Japan, Southeast Asia countries are lagging behind. And we believe that Sri Lanka digital platform can be a hub for further expansion in this region. And what's needed is standardization and integrated joint research project that can utilize the data and academia industry collaboration. Together with the national project, we are going to emphasize the need to do more research on Indian Ocean. And another panelist was the LPEM student. This student mentioned that LPEM is not just a course. For small island nation, LPEM course is very important for them to grow the future talent. And again, the panelists emphasized the need for the course, and I suggested to further expand the LPEM course. And lastly, we invited Mr. Jung Jun-hyung from KIMST. And Mr. Tong gave an overview about Korea-US Blue Food Project. And it was worth around 46 billion Korean won. And he mentioned that improving the cooperative platform is needed and a systematic approach is needed. And scientific community is essential for international research collaboration. So far, I have covered the content presented by 4 presenters and 3 panelists. As mentioned, there are some programs provided by kiosk, WOF, and the government. So throughout our session, we tried to cover what kiosks provide. We had around 100 participants. I guess 60 to 70 were foreign participants, and there were high-level government officials. You could see that World Ocean Forum is truly a global forum. Thank you. Please
give him a big hand. So they had the 4 presenter and the 3 panelists, and they talk about the joint research program made by the kiosk. Thank you for your summary. Next is about the shipping and the port session, which was moderated by the Kyubon Kim. Please, floor is yours. So our shipping and the port session was discussed under the topic of strategy to secure global transport network. Compared to what we expected, we didn't have that big turnout, which was a little regretful, but we could discuss that the global transport network should be secured for the future shipping and the port industry. So we approached this problem from the various perspectives of seafarers and the legal foundations and the global supply chain. So we had 1 keynote speakers and 5 presenters. And also we had 1 more panelist for the panel discussion. If I summarize the older presentation, so the keynote speaker was Sang-geun Song, the CEO of the Busan Port Authority, and he talked about the roles and the visions of a port for the global transport network stabilization. Due to the various geopolitical issues, there is a disruption in the port and the global supply chain, and that was because of the lack of the visibility of cargo. He diagnosed, and also this mismatch of the data between the shipping and the port. In order to overcome such problems, BPA established the chain portal, which is the port portal, to monitor the smooth flow of the shipping at the port. And through the participation in the international collaborative mechanism, he promised to make a more fruitful result. And the next presentation was made by the director of JTTRI from Japan, who is the Fujisaki Koichi. And he talked about the strategies of the Japan to secure the global transport network. Japan has a similar situation as Korea. So in order to maintain the stable global supply chain, he said that global transport network is the number 1 prerequisites. So from the perspective of resilience of the supply chain, he showed us the Japanese strategies to secure the global transport network. And also, he showed the result of their research on the strategic securing of the global transport network. So he gave us a very detailed review about the research. And the third presentation was made by the researchers from the JMC, the Japanese Maritime Center. He talked about the Japanese effort to revitalize shipping and shipbuilding in Japan to secure the stable global transport network. WTO OECD was the standard for the Japan, so they complied by all the regulations of the international body, and based on that, Japan established the policies and the regulation. But due to the various geopolitical risks like Ukraine war and the also disruption of the supply chain and the trade conflicts, the basic structure of the shipping and shipbuilding has changed, he said. In order to respond to this, Japan built the Maritime Affairs Promotion Act, and they have the movement to restructure the shipping and the shipbuilding. That was requested by the public, and the review is going on in Japan. And the fourth presentation was made by Professor Jong-gil Han from Seongyal University. He talked about the global supply chain disruption and the response of the shipping companies. He emphasized the importance of the business continuity plan in case of the emergency. So he analyzed all the accidents or the risks based on this BCP plan. So as the important risk, he provided all the global disruptions, and he emphasized the importance and the necessity of the BCP. In conclusion, he said the BCP is a must, not an option, as a strategy for the shipping companies, global shipping company, to overcome the global shipping crisis, especially in the northern sea routes, like a high-risk sea routes. BCP is necessary, he emphasized. And fifth presentation was made by R&D team manager of the HMM. He talked about their responsive measures, the shipping company's responsive measures against IMO measurements. IMO MPAC 83 delayed the effective date of the GFG measures, and the shipping company, depending on the carbon intensity, they have to lower the carbon intensity. If they do not satisfy the criteria, they have to pay the huge penalty. And as the effective date was delayed, the uncertainty is growing again, according to him. So as a responsive measure, he provided HMM's strategies and effort they are making. And lastly, we had Jin-Won Kim from the KMOU. He talked about the maritime human resources through, he said, need for enhancing nurturing the maritime human resources through the analysis of the Ships for America Act. So following the shipbuilding competition in the US and in the world, so new protectionism is growing widely, and we need to analyze the meaning of this act. And then Korea has to put effort to foster the maritime manpower for the future, he said. And also he asked for the collaboration between academia, industry, and government. Maybe that will be the summary of our session. Thank you.
김규봉
Thank you, Mr. Kim Gyu-bong, for the briefing. And next is for the Blue Economy session. We have moderator Kim Min-soo, who will do the briefing. Please. In our session, we discussed sustainable coalition and cooperation within APEC economy through Blue Economy. Among 5 maritime policies, I guess that's number 3, Blue Economy and Blue Finance Hub. I can summarize that into 4 points. So first, we discuss about current status and how we progressed and how we reached a conclusion in the session and what we are going to do with the outcome of the session. First, when we planned out for the session, there was a common mission given to us. In the fact that we are living in the era of uncertainty, everybody agrees. But on how we are going to go beyond a wave of uncertainty, each session differed. In the Blue Economy session, we reached a consensus that it is difficult for a single country to go beyond that uncertainty. Therefore, the pre-assumption that we had was to join hands. So international cooperation is greatly needed. So that's why we selected APEC as a keyword. Using the keyword Blue Economy, we tried to come up with ways to go beyond the wave of uncertainty. As this year is the year of APEC for us, in May this year, we had APEC Ocean Ministers meeting. We reaffirmed the willingness to further advance the maritime industry, and inclusive growth and cooperation was suggested throughout that meeting. As you know, next week we are going to have economic leaders meeting in Gyeongju. Taking that momentum, and as World Ocean Forum tries to suggest a solution, we try to find our own solution for the Blue Economy. And second, the program, if you read the program book, you may realize that we don't have any presentations in the session. We only had 5 panelists, and we didn't provide any overview of the program. The reason why we decided to do so was because we believe it would be difficult to find a solution with only some presentations given and a short discussion being done. Instead, we decided to do long panel discussion. We invited experts from APEC countries, and under the same subject, we decided to exchange our views. And again, we decided to do Q&A with the audience, but it was difficult to entertain questions from the floor, but instead we could use that time to do in-depth discussion among panelists. And we tried 2 methods. First, we had a best practice sharing for APEC, among APEC states, in terms of Blue Economy, and discuss how we are going to bring that into APEC collaboration. And based on that collaboration, if we take a step further, UN SDG will be completed by 2030, so we will have to be prepared for post-SDG. And that topic was also discussed during our session. And third, session conclusion. It is difficult to cover all the conclusion that was presented by our panelists, but instead, we suggested 5 collaboration methods. First, systematic governance is needed for blue economy collaboration. So within APEC, maritime issues and blue economy issues, there is no governance or consultative body, so we discovered the need to form a TF team. And by nation, we have different governance structure. In case of Korea, we have MOF, which is a central governance control tower. And next year, MOF will celebrate 38th anniversary. And we could produce some achievements in terms of blue economy. We decided to share the knowledge that we gain through that process. And second was about information sharing platform. Through APEC, we could share the knowledge on maritime and fisheries and oceans, but we don't have any data platform. So a second suggestion among our panelists was to have a data platform for APEC on blue economy. And the need to develop APEC's own blue economy technology was emphasized by panelists. The concept of blue economy is quite complicated, but you may think of it as this way. Everything that we have discussed so far belongs to blue economy sector. Creating value out of human activity is the definition of blue economy, and it's quite wider. We also think about ecosystem value and invisible value. We transform them into economic indicator, and to have a sustainable environment, blue economy's concept is applied. From that aspect, the potential of blue economy is not just about economic activities. We can use natural capital. There's a UN guideline to transform natural capital into economic indicator, but each country approached differently. Therefore, we need a common standards and indicator for the natural capital, and how we are going to assess the blue economy progress was important to be standardized, and that was the third point. And another thing, and Mr. Jang Ha-yong mentioned this before, and Mr. Martin Kering, who delivered a keynote speech, mentioned this as well. Finance is really important. APEC Blue Economy Finance, creating that is really important. Blue Economy Finance will support startups and entrepreneurs. Indonesia is the first ever country in Asia to have a Blue Economy Fund. And last year, they have published around 200 million Blue Economy Fund, and they have invested the money in many different fields. And the panelists mentioned that a sustainable fund of around 200 billion Korean won is needed. In order to have Blue Economy Fund, we need a milestone and momentum. Within an APEC, we need that APEC Blue Economy Fund, and that was suggested by our panelists. And fourth, APEC Blue Economy project is needed. Best practices by each country should be shared within the region so that we can have common knowledge. Korea shares the same thought. In case of fish villages and coastal cities, we have some problems of aging society and reducing population. Japan has Umigyo policy for fishing village, and we also have fishing village revitalization policy. And then sharing the best practices of that Umigyo and Korean fishing village revitalization project will be greatly beneficial for APEC region. So by state, by country, or by municipality. In case of Korea, we have own policy by different municipalities, so we need to share that practice. That's what's suggested by the Republic of Korea. And lastly, natural capital is not calculated within the economic accounting. So we need to recognize the natural capital, and what we are going to do is to make a carbon trading system within APEC. overseas, they have introduced blue carbon credit system. So APEC will have to consider introducing blue carbon credit system as well. And then the credit system you can utilize the seaweed blue carbon indicator to do their carbon accounting. We have some project related to blue carbon for the wetland. And APAC Blue Carbon Credit Initiative was what's suggested by the panelists. So these are the 5 projects that we have discovered so far. So next steps. Each country conducted a lot of event, forum, and seminars related to blue economy, and it would be beneficial for us if we can join hands in doing those forum. And next year again is 30th anniversary of MOF. And if we can do the celebratory ceremony together with the knowledge sharing event or best practice sharing event, I believe it would be beneficial for the country to share the knowledge with the APAC economies. And we have that plan together with the MOF. And in 2028, we are going to host UN event, and in 2030, we will prepare for post-SDG. And next year, WOF will celebrate the 20th anniversary. I hope that we can take that momentum to revitalize blue economy sector. That's all. Thank you.
네, 감사합니다.
Thank you for your comments. Mr. Kim talked about the discussion about the blue economy. Do we have Daesung Lee here? Oh, not here yet. Okay, then I will invite Chang Mo Ma to sum up the fisheries session. Hello, everyone. I am Chang Mo Ma from the KMI. I'm Fisher Research Division Director. We had a somewhat different session from before. We actually the fisheries, the people from the fisheries industry joined, and we also had the foreign speaker to deliver the presentation. We only had the online presenter, but this time they joined in person. So we had the meeting with the OECD people and on-site the fishery people together. Depending on the international regulation, the international norm and regulation directly influence the fisheries on site. So usually the international organization was presented by the experts and the national representatives. However, during the meeting, the fishermen who are doing the king crab said the global warming is too fast. Their production decreases down to half. But the governments are using the statistics 2 years ago. So the government also catch up with the speed of the global warming the fishermen feels on site, because that statistics are sent to the international organization, and the international organization make the regulation based on the 3 or 4 years ago status. So that was a very meaningful discussion, because that was a very good insight for the OECD. Because the fishermen wanted to give the statistics and the data to the KMI to analyze the situation. And the OECD realized how the fishermen feels in the field. And the most important thing in this era is to collect the real-time data to come up with the responsive measures. OECD is collecting the national data to send them to the WTO. And if the national subsidies are influenced by the WTO and the international organizations. So OECD suggests that spending subsidies in a smart way can set the direction and the future of the fisheries. So I realized that I have to deliver the messages and the data from the field, and then to discuss the more the practical and the viable solutions. Overfishing and the global warming gives a dent to the fishery industry. So I was the first speaker in the session. Due to the climate change, there was uncertainty, the investment decreased. And due to the decreased investment, there was a gap in the technologies and the fisheries and making the bad cycle. So the lack of technology and the lack of the human resources are continuously going on. So we have to sever those kind of bad cycle. And even in the low carbon emission scenario, the Asian countries, including Korea, have active fishing, and the biomass will decrease. So last year, the total fisheries was the 810,000 tons, but reportedly it will go down again. So we need the responsive measures against this. And the OECD pay high attention to the national subsidies. Across the world, $10.7 billion are given as the subsidies to the fisheries, but that is used for the management of the fisheries. So how can we deliver such kind of the subsidies to the small scale and the micro fishermen? We have to provide a tool for our fishermen to overcome a wave of uncertainty. We also had a chairman of the academic association, like a fishery science and the fishery management association, and they said blue carbon credit using the seaweed are utilized in Japan. So maybe we can use that as the source of profit for the fishermen. And we also, the participants from the Busan City Council, we have the low seawater temperature symptoms, and we have the strange global warming symptoms. And also there is a lack of the oxygen in the water, and there is the serious problem in the South Sea of Korea, so they asked to solve this problem too. We also had the participants from the Ministry of Oceans and the Fisheries. They also talked about transition to the PLC, and that they wanted to build a data platform for the technological R&D. the overall keywords was that the fisheries and it is all about the green and technology. Fisheries has the long value chain, the consumption and the distribution and processing and the export. So from sourcing is done from all countries around the world, and the consumption is also in the various countries. So the data validation for the eco-friendliness is very difficult. So the eco-friendliness and the data digitalization will be the competitiveness of the fisheries in the future. And the fisheries subsidies should be innovated. And also we need the data management for the better fisheries in the future.
네네, 마창모.
Thank you, Mr. Ma, for giving the briefing on fisheries session. I guess we could hear from the field, and it was really impressive. Next, I would like to invite Mr. Yoon Hee-sung to get a briefing on maritime finance. Nice to meet you. I am Yoon Hee-sung from KMOU. The theme that we had this year is going beyond the wave of uncertainty. And in the financial sector, we see risk. Whenever we use the term risk, we think of volatility and uncertainty. In the finance session, the big theme was risk. And we organize our sessions under the big keyword of risk. The scope of the risk include market risk related to the transportation price risk, and there's regulation risk. And another element is geographical risk, geopolitical risk, and foreign exchange risks. So those 4 keywords were the topic of our presentation. Related to transportation price, from London University, we have speaker Nikos Nomikos. And for regulatory risk, we had Mr. Jung Yoon-gu from ENG. And for geopolitical risk, we have invited Mr. Choi Jae-sung from Clarkson. And for foreign exchange risk and Korean currency finance, we have Mr. Lee Dong-hae from Busan International Finance Promotion Institute. So let me briefly summarize what the speakers had suggested during their presentation. Professor Nikos Nomikos mentioned about how we can hedge the transportation price, and he suggested derivatives, especially FFA. So what was impressive in his presentation was that FFA, if that is joined by, if compared to other markets, the correlation is quite low. FFA can be used to diverse the risk, and it can be used as a good tool. And financialization was another term suggested by Professor Nikos. When the risk is controlled, then FFA can be used by non-maritime sector to approach maritime sector. This means that FFA market, when there is more liquidity in the FFA market, then there will be more activity, and maritime sector will be able to use FFA. But non-maritime sector, for example, commodity sector and financial sector, can utilize FFA to control their risk. However, in Korea, utilizing the FFA, many people stand negative, and it is not that actively used. And there were many questions related to that, and then speaker addressed those questions. For example, what kind of measures are needed to revitalize the FFA market to do risk management. And moving on, Mr. Jung Yun-gu had made a presentation about Basel IV and risk management. This speaker had worked in the field for so long, and recently, related to Basel IV, he published 3 papers related to the topic, and he got his doctoral degree based on those academic papers, so we could learn a latest trends in Basel IV, so it was really helpful. Related to Basel IV and how we should approach that, he gave the definition of the terms and explained on how. And he explained how to calculate risk-weighted assets, and the different aspects of other common assets and risk-weighted assets. From the bank perspective, the impact of Basel IV, he used the term fly to quality. When the shipping companies have that quality, then bank will be able to select those shipping companies. So when the shipping company is low in scale, then they will have difficult time securing the funding. So he suggested that for small and medium-sized company, finding the funding source will be an important task that need to solve in going forward. And Mr. Choi Jae-sung covered geopolitical risk factors. As he is the CEO of Clarkson Korea, he had many materials and gave an ample explanation. I believe that many participants will be able to gain his entire insight using that material, so please refer to that. And globally, in recent years, he covered all the different technological options in the field, focusing on USTR. The measures of Korea in USTR and other ripple effects that it gives to Korea. For the cargo owner, there were a lot of pressure from the cargo owner to go green in case of PCTC and container vessels. Big players in the global shipping industry, they placed many orders to China for the new build. Of course, this is a bad impact to them, but in case of Korean and HMM, we place order to Korean companies, so we have an upper hand, and that's what's suggested by Mr. Choi Jae-sung. And he also covered the impact to shipbuilding industry. And Mr. Lee Dong-hae mentioned ways to hedge FX risk and how we can utilize Korean currency finance. In case of power generating companies and energy companies in Korea, for example, coal gas, there are some capital flow that they need to pay in dollars and gain in Korea. So signing a contract in Korean currency can be a natural hedging method for them. And the speaker suggested that we need to utilize that strategy more actively. And for local financial centers, for example, in Busan, there are some. These institutions lack the capacity to bring in dollars. But at the same time, I think he mentioned that this is a good opportunity for them to use a shipbuilding finance in this way. So in Korea, we pay 50% of the new shipbuild costs in Korea. He suggested this is a good way to hedge FX risk. And there were many new ideas suggested. While operating the vessel and we sell that vessel, we gain US dollar. And when the currency volatility is high and when people prefer safe asset, then when we sell the vessel, then the investor want to have safe asset, and when the vessel is sold in US dollar, they can get benefits out of that. As mentioned, we have covered different topics related to risks. And again, we have discussed what we need to discuss in the next WOF. As a planning committee member, I thought that whether it be the root cause of repeated failure, we need to do pro-cyclical investment. But instead, we need to change the pro-cyclical investment to go in reverse. And I hope that we can discuss this issue next year. Because in the natural state, pro-cyclical investment may feel natural to the shipping and the maritime sector. Then we need external force to do counter-cyclical investment, and we need to think those elements that make us move to counter-cyclical investment. We need ways to induce more individual investment and other different methods of financing. To induce counter-cyclical investment, what's important is to have predictiveness in the market cap of shipping industry. And the predictive method for the economy so far failed. So that's why some people say that it is difficult to predict and prediction is meaningless. Against that backdrop, using AI analytic model and generative AI, then if we can increase the quality of prediction, and that can give a positive impact to shipping industry prediction. And I think that's another good topic that can cover in 20th WOF. In the finance session, I believe that our planning committee members contributed a lot, and speakers were so good. 2 had global presence and 2 are from local. I believe we had a valuable session thanks to that. Thank you.
예, 감사합니다.
Thank you for your comments. So he said that the Blue Finance the session was very successful. So please give him a big round of applause. And he also suggested the topic for the 20th WOF next year. Then we will have the Kangwon An for the shipbuilding session, which lasted whole day today. Okay, so I had a long session today, so I'm so tired and sleepy now. So why am I telling you this? Because if we are not doing this good, everybody will fall asleep. So that's why I'm telling you this. And our session was quite special. So I more than joined like 60 times in the conferences, but we have something special in our shipbuilding sessions. Because conference is all about talking about what we will do in the future, and that's the purpose of the conference. Conference is not a place we brag about, but the place what we should be prepared for in case of uncertainty and emergency. So when I structured this session, I had some disagreement with the committee members, but I wanted to talk about more like a future-oriented topic. So I sent letters to 500 people to make a survey, conduct survey about the topic and questions. And then the structure the session. So I gave the questions to the panelists in advance. So we had a total 6 hours of the 4 hours of presentation and the 2 hours of panel discussion. I was wondering whether we will talk about the northern sea routes because so many conferences are talking about it. So I was worried if it can make people tired. So talking about the northern sea route from the perspective of like icebreakers and the fuel, the vessel fuel, and what kind of the propulsion we can use was the topic of our presentations. We had presenters from MT Korea, who is an expert in the shipbuilding. He talked about the challenges and opportunities of the icebreakers. And he covered the marketing and the navigation requirements for the operation of the icebreakers. I invited 2 foreign speakers. One was a Stavros Hatchigrigoris, who gave the order of the 170 vessels, which are all high-end. He's a very, very famous man in Europe, and he was the former CEO of the Marine Gas. He is also the chairman of the technical committee in Europe. He decided to give the order to certain countries, but he always ordered the new technical challenges to us for the shipbuilding of the new vessels, and he gave the great comments, and he provided the great insights to us. So we talked about the agenda favored by the ship owners and the shipbuilders, like fuels and the strategies. And also we talked about the strength and weakness and the opportunities and threats of Korea shipbuilding industry. So it was the early morning for him because he is based in London. So he joined our conference despite his busy schedule. Also, we had a Professor Lee, who has a lot of information. KK Lee from the Zorner Energy Systems. And he's Korean, but he is aware of the global trends of the green ship. And he gave us the presentation about the next generation eco-friendly fuel-based green shipping corridor optimization technology. And also the Professor Jung-ik Lee gave the presentation about the SMR. So nuclear energy is regarded as the future fuel instead of coal or fire. And nuclear energy is regarded as the carbon-free renewable energy, but due to the government policy, the students are not applying to the nuclear engineering in the Seoul National University anymore. So anyway, the Professor Lee talked about the SMR, and our companies are investing a lot in the SMR for the future long-term future energies, the renewable energy and the green energy, ammonia and hydrogen, still have the high costs. So many prefer the SMR, according to him. And also we invited Taejin Lee from the Hyundai Heavy Industry. So digital transformation in the shipbuilding industry is almost 60%. The Hyundai Group made more than 300 ships with a much less number of people now, and all the welding job is done by the robots. So he talked about the AI and the physical AI in every area, and he gave a wonderful explanation about it. And he gave us a lot of trade secrets of the Hyundai heavy industry a lot. So we could see the huge change and the transformation in the shipbuilding area. I always suggest the deans and the president of university to change the curriculums, which can be proper for the industry. And also, one of the participants in the floor asked a question, and what kind of human resources we have to nurture. In the panel discussion, I gave all the different questions to each panelist. Across the world, many people say that the Korea faced the boom of the shipping industry, but the small and medium-sized shipyard is being sold to the other big companies. They cannot survive. And Daehan Shipyard tried to do the exit through the IPO. So what will be the survival strategy for the SMEs in the shipping industry? So that was the special discussion in the honor panel discussion. We need to have the small and medium-sized equipment and the parts companies in the shipbuilding industry, and we have to seek for the collaborative measures with those companies. We had a shocking incident. So we gave the technology and conducted research, but the order was given to the Chinese company. So we shouldn't have this kind of happening again. So that's why we wanted to discuss about those kind of practical issues in the panel discussion. And currently, Korea import 60% of the parts and equipment from other countries. Because of lack of the test facilities. So we make money, but we give all the money to the companies in other countries. So we have to have like a strict reality check, and we have to come up with the measures to prevent them. And the Dr. Kim from KR talked about the IMO MPAC 83. There was a 1-year delay, and he also talked about the responsive measures against it. And Mr. Yoon from the Samsung Heavy Industry talked about the green ship. I ask questions about the 10-year cycle in the shipbuilding industry, and I asked the future of the shipbuilding industry. So we see a huge change in the organization and the structure of the shipbuilding industry. And Mr. Song talked about the way we should go forward in the future to survive this uncertainty and the evolving changes. So I believe that this kind of challenges and actual difficulties should be discussed in the panel discussion, but usually in the conference they talk about what they did well. So I wanted to do it again in the next conference. So this shipbuilding session was very long, but we had the great support and the reaction from the participants.
네, 안강훈 차장님 수고 많으.
Thank you, Mr. An. As the shipbuilding session spanned from the morning and afternoon, it would have been difficult for you to arrange all that, but thank you. And next, let's cover international politics and maritime power. And let me give you the briefing because I was the moderator for the session. So in the international politics and maritime power session, this was the first time that we had the session in World Ocean Forum. When we planned for the session, whenever we talk about maritime power, we only have discussed about naval power. But maritime power is something bigger than that. So for the presentation, Mr. Lee Jong-ho, former Chief of Naval Operation, gave a presentation. And we have invited former Ambassador An Young-jip. And related to the maritime law, we have invited Mr. Yang Hee-chul from Kiosk. And then we had a panel discussion. And we focus our discussion for the private sector maritime power. We have invited Mr. Kim Chang-jin from Maritime Association. And we invited Mr. Shin Hyun-ae from Korea Distant Water Fishing Industry Association. And related to shipbuilding and maritime plant, we have invited Mr. Choi Koo-jong, and all these need human resources. And as a representative of human resources sector, we have invited Mr. Kim Jong-tae for Marine Engineers Association. We had 3 presentations and 4 panelists. And let me give you a summary of our session. Former Chief of Naval Operation mentioned that the definition of maritime power is a comprehensive ability to control the sea and the land. And as mentioned, comprehensive power includes official sector and private sector. And he covered the history, for example, through the war at sea, Rome could gain the power, and he covered the history of how the empire built up their strength using ocean power. And Korea stands at 5th in terms of military power, but in terms of ocean power, we rank 7th. And in case of Japan, they stand at 8th in terms of defense power, but 6th in ocean power. And he mentioned that we are better than Japan in terms of maritime power. To further strengthen maritime power, we have discussed some strategies, and you mentioned that maritime community is greatly needed, and he dubbed this as Band of Brothers, which is a maritime community of in the international field. And as naval power is directly related to the defense power of the nation, he mentioned that we need to have an integrated control tower for that. And second presenter, Mr. An Young-jip, former ambassador. He shared his experience as a diplomat. We frequently heard of this before, but he mentioned why China couldn't build up their power in the ocean. And what was impressive in his presentation was the UK. He said that they are rule setter. They have the headquarters of IMO, and they are doing a lot of dispute settlement in terms of maritime. And Greece is someone who holds big shipping companies. And Singapore, he mentioned that they are a service hub, and they have the biggest bunkering port. And for China, he summarized that they are a new rising power. In Japan, they are traditional maritime power, and they have the third ranking shipbuilding sector globally. And he suggested the future direction of maritime policy of Korea. On that, he suggested we need to play an active role in IMO, and they suggested to use the embassies across the world to strengthen our power and to accept or adapt to the new technology more quickly. And Mr. Yang Gyu-chul majored in maritime law. As he is the maritime law expert, he covered all the issues related to maritime surrounding Korea. And China announced that they're going to launch a satellite on a ship. And this was what has been covered by Mr. Yang. And he also covered the controversy over Chinese attempt to have a drilling facility infrastructure at the Western Sea of Korea. And Taiwan Strait. And whether we see that as an EEZ or domestic water, he mentioned that there can be a different conclusion to the Taiwanese Strait. And we had panel discussion with four panelists. Mr. Kim Chang-jin from Shipping Association. And this is a union, not an association, focusing their efforts in inland water. They have 2,400 members under the union, and they have 240 vessels that belong to them. And he mentioned that there is, again, a control tower that encompasses all the sectors. And second, Director General Shin Hyun-hae from Distant Water Industry Association suggested why distant water fishery is so important. Currently, we have around 200 deep-sea vessels, and 200 vessels are owned by Koreans, and 40 are extended deep-sea business vessels. And last year, the fish catch was around 770,000 tons. And in the coastal region, we had a similar amount of fish catch last year. Deep sea fishery is beneficial for the food security. By reaching an agreement on deep sea water, it plays a role in expanding the country's sovereign water, and it does have some diplomatic effect. And it is related to the ODA project as well. And technology development is taking place for the deep sea fishery as well. And in going forward, he mentioned that whenever we call him to be the presenter, and they will participate. And last comment made by Mr. Shin is that the captain of the commercial vessel is around 150 million Korean won, but for deep sea vessels, the annual salary of the captain is around 1 billion Korean won. Just like the lawyer, they need to pay around 400 million as a tax because this is not a special occupation. That's why many Korean captains register their business in Taiwan or some other countries. And that case amounted to 100 this year. So he suggested that easing the regulation on taxation for the captain should be introduced because lawyer gaining 1 billion a year and captain gaining 1 billion a year are totally different because working condition for the deep sea captain is not that good, and they need to spend a year at sea before coming back home. So he emphasized that regulation should be changed, taxation should be changed. And next, Mr. Choi Kyu-jong from Maritime Plant Association mentioned that Korea shipbuilding industry takes up huge amount in the economic development, and we are assisting the U.S. through MASCA initiative. And next, Chairman Kim Jong-tae from Korea Maritime Engineers Association, that it is important to raise public awareness on maritime industry for general public as well. And he stressed the importance of maritime engineers. So it was shocking to hear that during the World War I and World War II, around 40,000 seafarers died during the war and 4,000 vessels were submerged. And it was shocking to hear that. And recently, in the U.S., SHIPS Act was introduced to protect their own shipbuilding companies and to protect their own shipping companies. And they have a plan to nurture their own marine engineers for the commercial ships. And likewise, he introduced a similar initiative to be introduced in Korea. This is the briefing for the International Politics and Maritime Power session. And next, Mr. Ho Yun-soo will cover Busan City Special Session.
So in our Busan Metropolitan City Special, we talked about Busan's development path as a hub city for the Arctic route. So you know about this very well, but we had the Dr. Jung Sang-yeol from the CRISO, and also the Executive Director Mads Kvist Frederiksen from the AEC, and the Kjell Stovik from the CHNL, Nord University, and we had Ji Kim from the KMI to talk about the recent trends of the Arctic route. So I could learn a lot from all those presentations. So through the panel discussion, we brainstormed several ideas, and we talked about how Busan can become the hub for the Arctic route. And also, not only Busan, but also for the countries, we try to find the measures. Like a temperature of, through the activities of all these equipments and the part industry, they said that we have to foster the industry for those kind of parts and suppliers. And also economy collaboration should engage the local people and the indigenous people. And still many are using, mostly they are using the oils, and we have to use the green fuel for keeping the environment of the Arctic route. And also the Kjell Stovik, the director of the CHNL, gave the idea about the green shipping corridors, and they gave some ideas and the data, and it can be expanded, and so that we can secure the green shipping corridor from the Europe to Korea. And the 5 local experts came from the BPA and the KMI and the Donghua University. So BPA tried to become the hub city for the NSR by preparing all the infrastructure, and the researchers in the local area wanted to seek for the industry which can link with the port and the local area. But the one thing I really learned a lot was about the logistic, because my major is logistic. So the Northern Sea routes and the global network trade is increasing, but mostly it is an oil tanker or the LNG carrier. But the Busan port is the hub for the container vessels, so it will take time for the container vessel to move around freely. And also the Dr. Jung Sang-yeol said that they will be revitalized by 2025, but it takes just like we have just 5 months or 6 months for the regular line. So the container, we had the concern or doubt about the revitalization of our container vessel. And the Chinese 5,000 TEU started their container vessel through the NSR to the Rotterdam into the London within 20 days. Usually it was 30 days, but they reduced it to the 20 days. It was shocking. So all those cargoes in this ship, well, was that items. It was very interesting because I had an interest in this NSR, like because all the container goods can be frozen in the NSR, but most of the cargo was the lithium, like the self-heating materials. So when they go through the Antarctic routes, there was a problem, but these self-heating products, if they go through the NSR, they can have a benefits, without any defects, and those can be delivered through the NSR. And the duration could be reduced by 15 days. And lithium products was all the the NSR cargo freights that were mostly, it was at a low ended value, but the lithium is a very high-end product which is usually shipped through the airplane. So there was a creative idea out of the box. So if we have those kind of creative ideas, maybe we can have we can enjoy more benefits of the NSR to save the time and the cost. So only through the scale of economy, the business modeling of the cargo freight can be earned. So if we have a creative idea like this, we can have the more benefits to deliver this kind of high-end products through the NSR from the Busan. And that was the great insight from the panel discussion. So I think based on that, maybe we can have more research about it, because the Busan port is a container port. So we can have more considerations for being the hub city for the NSR.
허윤수 부원장님 마지막에 말씀하신
Thank you, Mr. Ho Yun-soo. You have mentioned about container alliance. Even though we may not repeatedly use the container on that route, but if we select certain product type that fits the route, that can be a good idea for us to explore the Arctic Sea route. Next, I would like to invite Ms. Jo Jin-soo from Busan Metropolitan City. Nice to meet you all. I am Maritime Capital Policy Director of Busan Metropolitan City. The World Ocean Forum has come to the final day. Through 13 sessions, we have discussed maritime port, maritime bio, maritime finance, and we cover various fields with experts in various fields so that we can find a way forward for the future of maritime. I believe that this forum was sponsored by Ministry of Finance and Busanilbo, and together with Busan Metropolitan City. And today I would like to brief to you about our maritime capital policy set up by Busan Metropolitan City, the progress and the future. The theme of this year's forum is going beyond the wave of uncertainty. But we are truly living in an uncertain time. Now the sea is not just a space we do economic activity. For the oceans, we discuss about international cooperation, climate change, and it is a strategic space. This year's forums covered many different topics at this important time. And for Busan, it was a meaningful time for us to think about how we can make further efforts to grow us as a global hub. In Busan City special session, we discuss about Busan City's future direction to become an Arctic transshipment hub. As Mr. Ho Yun-soo briefed this, I would like to skip that part and let me cover future policy direction. And I will reflect all that has been suggested by WOF, and I will reflect that to the industry as much as we can. In August, Busan City announced our vision to become global maritime hub city, to become global top 5 maritime city, and we suggested 3x1 strategy. And that is, we are going to pursue 3 innovations. Space innovation is first. We are going to make maritime logistic cluster, and through industry innovation, we will transform our industry to go green and to have cutting-edge technology. And third is talent innovation, to explore Arctic sea route and to nurture maritime and fishery talent. By linking that with Arctic sea route strategy, Busan will not only become a global maritime hub, maritime city, we are going to become a maritime hub. This strategy, together with the central government maritime capital initiative, this goes hand in hand. And we have in a detailed action plan according to that vision. Recently, in the maritime sector of Busan, there were some practical change taking place. Last week, it was 16th of October. We had a meeting with Infrastructure Center, IHO Summit. They confirmed that they will establish IFO Center in Busan. And in June next year, they opened their office. When that center can start to do business, then Busan will be the leader of standardization of water-related data. And this will be a good momentum for Busan. And in March next year, a launch of small satellite called Busan-Sat is scheduled. With that satellite, we will be able to observe the ocean better, and this is a science-based approach for Busan to grow into a scientific city. As you well know, in December this year, the MOF will move to Busan. The policy center should get closer to the field, so that's why the MOF is moving to Busan. And this shows that Busan will expand its role as a maritime city. In addition, together with Gyeongnam and Ulsan, we will form a cluster so that we can lead the country to become a maritime powerhouse. Likewise, Busan is adapting to and leading the changes of national policy and adapting to the paradigm change. To become a global maritime hub, we have all the things needed. Every opinion suggested through World Ocean Forum and every discussion taken place, I think it was a good opportunity for Busan to envision the future steps in detail. Busan City will do our best to incorporate all the things into our policy and put it into action, and will give constant support. Lastly, I would like to thank Mr. Moderator and all the planning committee members and speakers and participants to the forum. Thanks to your efforts, the World Ocean Forum could have been successful for the past 19 years and have become a major ocean platform of Korea. I hope that this forum could grow further as a global maritime policy platform. and Busan CDF will contribute as a partner of WOF. Thank you.
예, 조진수 거장님.
Ms. Ji-suk Jo, thank you for your summary and like your thank you message to all of us. I believe that this is the time for closing the epilogue session. So I believe that we utilized our time very wisely. So the 10 people gave us this summary about the older session. So I think there will be no problem in making the booklet with all the comments from our moderator. Thank you very much for your participation. And we had a successful event of 19th World Ocean Forum. And also in this epilogue session, we had a great report. So I hope that you have great networking time after this. All the scripts and presentations are uploaded on YouTube channel, so you can refer to all the information online. Thank you very much.
Thank you, moderator. This concludes our journey for the past 3 days. I would like to thank all the presenters and all the moderators for each session and Mr. Kim In-hyun. And what was impressive was that we had the keynote speaker Martin Kering here with us. I would like to thank all the people who stick through, and this concludes our World Ocean Forum. Next year, we are going to celebrate our 20th anniversary. It's a year that we become an adult, and I have high hopes that World Ocean Forum will grow further. We will meet you again next year. This concludes the World Ocean Forum, and I am Lee Mi-sa. Thank you.